Good afternoon, everybody. Thank you, Dr. Salman, for organizing this workshop. Briefly, I will just say a couple of sentences about our project. It's about developing the traditional handicraft system and bring it to the academia. Mainly, the main goal is to transfer this vast craft experience and knowledge into the academia via courses and training courses and vocational courses. In that, we are aiming at preserving the traditional process in terms of design, training, and marketing. It's a relationship between the academia and the craft society. The craft society will benefit in terms of design process. This is what we are going to teach them. They are going to teach us the training and the production process, which will help to generate more competences for our graduates, and by that, they will increase their opportunities for getting a better job in the labor market. And the whole project is based on the potential criteria that is wanted by the labor market. So there is a good cooperation between us and our stakeholders that represent the craft society in Jordan and Syria. Based on the mutual relationship between us and them, we designed the courses that are going to be involved in the project. If I can quickly say that basically they are based on, let me try to share my, yeah, I'll share my screen and okay. If you can see, these are the courses that are involved in the project. Mainly, we are having courses from a Department of Architecture, Interior Design, Applied Crafts, and some of them that deals with the energy and manufacturing from Department of Mechanical Engineering. As you can see, we have designed the involvement of the academia on different levels. We are involving the students from level 1 to level 5, from the first course that they are joining the university until their graduation projects. So mainly we have basic design courses. We have courses involved in the technical production of the drawings, like workbook drawings, and because this is an important part of production system, how to design and how to transfer the design into applicable piece of work, whether it's architectural, interior design, or a craft design process, industrial design, or object design, or any other design items. We have courses on the 3rd and 4th year, which also it's a design courses. We have courses to do with the conservation of architectural heritage, because part of the objective of the project is to conserve these traditional processes that exist within these craftsmen and to transfer it into the academia as a design and production process. That's why the relationship between us and the craft society, we will teach them and and try to develop the traditional designs and the contemporary designs that have a market within the labor market in Jordan, Syria, and within the region. And they will give our students the knowledge of competencies that is needed in terms of craft design and object design and industrial design that is needed by the labor market. So it's a mutual relationship between us and them. By that, we choose lots of courses that involved in conservation of architectural heritage, preserving the architectural heritage, rehabilitation of these items as part of the project. Also, all our students, they have to do a practical training. We took the course of practical training at least 2 or 3 weeks from this practical training, which sometimes it's extended to 3 months. These practical training will be developed either within the 2 centers that's going to be established, part of the project, one in Zaytun University for the Jordanian universities, and the other one, Tishrin University for the Syrian universities. But the training courses and the training programs and the vocational courses will be designed by the craft society. some of the implementation will be within these centers, and other will be training within the workshops of the our stakeholders, the mass craftsmen. Also, we have courses to do with interior design application, in terms of furniture design, and product furniture design in terms of design and application. As we said, also we have manufacturing and material properties, casting material, which is from mechanical engineering. That's why it's part of the dissemination of the project that different departments are involved in the project. Okay, we agree that the main core is architecture and interior design, but we have, besides that, applied crafts and manufacturing. So departments of mechanical engineering, interior design, architectural engineering, and applied arts, all of these departments are involved with the project, which will help that to increase the number of people working on the project and getting benefit from the outcomes of the project. Also, we have courses to do with the modeling and workshop modeling and architectural elements, and to go into application of applied arts into ceramic, pottery, and different handicraft aspects, like also weaving and departments of fashion design. And actually, based on this project at Zaytuna University of Jordan, they established a fashion design department as a dissemination or one of the outcomes of this project. It's now started for last year, so now we have it for one full year, and it will continue the second year, hopefully by next September. So this is, in a brief, the cores that are involved in the project, which is a huge spectrum of courses and departments that are involved in the project, which we think that this mixture of different departments and different courses will enrich the project and enrich the dissemination of the project outcomes in direct partnership with the different stakeholders that represent different aspects of the project. So mainly this is what I wanted to say as an introduction about the HANS project and the courses involved, and the main goal of the project in terms of preserving the traditional craft process and supported by bringing it and housing it within the academia, and also getting the students involved in different design opportunities, design prospects in terms of understanding the traditional design process and developing into the contemporary design process, which will help the craft society in marketing their products. So there's a third dimension for the project, which is related to the marketing. How we can help the traditional craft society in terms of marketing their products, and how we can help our graduates to start their own business and the new businesses and small businesses that is related to the craft design and manufacturing, and also as a marketing process. Again, I would like to thank Professor Salman for organizing this workshop, and I'm sure that looking at the lectures, we will enjoy a different spectrum of these lectures. Professor Salman, thank you very much for organizing this workshop, and the panel is all yours. Thank you.
Thank you very much, Dr. Luay, for the interesting presentation and for the nice and kind words. Thank you also for organizing actually all the project and coordinating on the activities of the project. You afforded many efforts to that the project in spite of the problem of pandemic, the project activity actually are going very good, also, according also to the situation. Thank you very much for your efforts with your team, Engineer Iman, and other partner. Of course, they contribute for the success of the project. And we hope that this workshop also will be success or will be a success activity in the framework of the project. Now, I welcome you again, to the lectures, and I will begin with my lecture. I hope that my colleagues, other colleagues, also will join us. Till now, I haven't seen only one colleague, but I think they will join us later. So please, can I have I free now? Can I?
Yeah, you can do share screen, Doctor.
Yes. Here, Belch, yes, here. So that can you?
Yeah.
Yes, we can see it now. Yes.
Yes, thank you. Thank you very much. I welcome you again to my lecture now, and my lecture is about the possibilities actually of using of solar energy in the framework of the project. How can we use the solar energy to make the production of the handicrafts more productive, more effective, and more environmental friendly? Therefore, actually, I thought about this lecture to show the possibilities of using of solar energy in also maybe as a course at the end. Maybe we can offer this topic as a course in the framework of the project. So the point at the outlook of my lecture is I will make a little or short introduction about the importance of using of solar energy. Sorry, I stop. Of solar, I make so sorry. I think it is now better to see. Yes,
it's better as a slideshow.
Yeah, thank you. So I will make a short introduction about the importance of using of solar energy as a clean energy source. Then I will present maybe the possibilities of using of solar energy, the work principle of photovoltaic cells and possible technologies, components and technical parameter of PV systems, and how can a PV system as a photovoltaic system be dimensioned, and some references, of course, belong to the lecture. Now, why using of solar energy in Syria and Jordan is important? As you know, the availability of solar energy in Syria and Jordan is very high. More than 300 days per year, we have sunshine. And actually, at least average, at least 10 hours per day. And this solar energy potential in Jordan is enormous. And the average solar radiation is between 4 to 8 kilowatt hour per day and square meter. This applies a potential of about 1,400 to 2,300 gigawatt per year annually. That is a huge amount of energy, which we can really use it. In Syria, the situation is similar. The average rate of the solar radiation is about also 5 kilowatt hour per day and square meter, and really in most regions of Syria or Nigeria and Jordan is more than this number, but that is average number, which is equivalent to about 2,500 kilowatt hour per square meter and year. As comparison, in Germany here, only about 1,100 or 1,200, depending on the region. That means double solar energy availability against two other countries. Nevertheless, in Germany or in Europe or in other countries, the using of solar energy or renewable energy in generally is more than also about 10 folders as in Syria or in Jordan. That means we have a big potential to use the solar energy also in a small handicrafts or in small objects, but it can be generalized as small objects or big objects. And for training centers, actually that is a very good possibility to supply these centers, training centers, either as universities or small training centers or governmental buildings. Actually, the use of solar energy is always available and is very easy. It's very easy to apply, but we have to have the willing to do this. We have to have the willing to do this, to apply this possibility in the practice. So also, as I said, as example, in Syria, per kilowatt peak solar installed photovoltaic cells, we can gain about 1,900 kilowatt hour. That means because that means the possibilities to effectively use this solar energy is actually very high. So, and also the using of solar energy, of course, is environmental issue, which is interesting for all. As you know, through using of solar energy, a huge amount of conventional energy resources, as in our region, gas and oil, can be saved, and many pollutants can be also avoided. CO2, NOx, SOx, and other pollutants, which actually is very dangerous for the environment. And through using solar energy or another renewable energy as wind energy, as example, we can avoid such pollutants, and we can actually contribute to the to a healthy life in the country. So not only here as example, I wanted only to show you that in Germany, in Germany, you see here the use of solar energy only as photovoltaic, not solar thermal. Photovoltaic, the development of using of photovoltaic as for supplying electrical energy, you see here the development is about after the 2000 years, it was at the beginning about 0 in gigawatts. That the installed energy, solar energy, is now about 50 gigawatt. That means actually that it is enough only from solar energy to supply Jordan and Syria and maybe Lebanon with electrical energy. That is 50 gigawatt only from solar energy, photovoltaic. And that is a huge amount. And actually this possibility can be applied in, in our countries, in Syria, in Jordan, in Lebanon, and where the sunshine is available. And it is available in the most regions. Sorry, I wanted to make also the state of art worldwide, but I think because of the time, I thought it is enough. It is known in the literature, in the internet. That is information which can be actually taken from the internet. So, first, also the technologies, that means the use of solar energy, photovoltaic, to produce electrical energy is a very high developed technology. At the beginning, and through this developing, of course, the specific prices of the systems has been decreased, although has been decreased very high. You see, as example, actually it was in the practice. So till the maybe 2015 was the specific price of module solar photovoltaic modules about 1,200 euro per kilowatt peak. And now we can buy such modules for 160 to 460 euro per kilowatt peak, of course, depending on the type of that modules and the manufacturer. That means, of course, here when we take monocrystalline photovoltaic cells, which are very effective, of course, they are more expensive as the amorphous photovoltaic cells, which has a lower efficiency, and the production, the manufacturing of such photovoltaic modules is more simplified, although more simple, more easy, we can so. So for your also only for illustration, I found this curve which shows the decreasing of specific price, capital cost of PV system, photovoltaic system, euro per watt. You see here in the 19th also years, as 1995 was about, for all technologies, was about 700 here or 7 euro per watt. That means about 7,000 per kilowatt, 7,000 euro per kilowatt. We see here we are now by 160, and now in this year or in 2020 for last year, we can take or we can buy a PV system for 1,000 or 1 euro per watt or $1,000 per kilowatt. That is, of course, average prices. And in Europe here, in Germany, actually we can take this number as this average, as I said, 160 to 460 euro per kilowatt peak. So actually, I wanted to make a short list about the specific costs. Sorry, one moment, please. I am very sorry, because that is the office, and it was very important call. But actually,
okay.
Yes, when it is when it rings, then I have to. Sorry.
Okay. It's okay, Doctor. It's okay.
Yes, we were by the market prices of the photovoltaic systems. Actually, I wanted to show you these prices only to make an overview about the possibility of use of the total system. As example here, of course, that is practice, that is practical prices. The PV systems and solar modules, the range of these modules between 160 to 460 euro per kilowatt peak. Inverters they are available for 182 about 275 euro per kilo volt ampere. Of course, that is the here appearance power. And the storage batteries also depending on the capacity, storage capacity, between 380 to 500 euro per kilowatt peak hour storage capacity. The system price, including installations, they are different, or the average here is very big relatively, because actually really that is depending on the BFO and the components of the system, the technology which we use, and of course the installation difficulties, whether the installation is very simple or somewhat difficult. Therefore, you see here the range of one says K installation, K system that is about between 600 and 1,400 euro per kilowatt peak. So now, which possibilities we have to use solar energy? As you know, the solar energy can either in solar thermal energy, can be used as solar thermal energy. That means we have to have solar collectors, and these solar collectors can provide thermal energy, which can be used either for heating and hot water systems, or for driving of solar thermal driving cooling systems, absorption, desiccant cooling, which actually this part here is our specialty as the field specialty as the solar cooling. Or we can also use the thermal energy to drive the power plants. Solar thermal power plants, they are very known. We have here solar concentrators, and we can produce a very high temperature, which can also produce an electrical energy, and this electrical energy can be brought to the end user of electrical energy. Or the most used part for production of electrical energy is, of course, solar cells, and the producing of current and power through conversion, or converting the solar energy in electrical energy through the photons, also energy of photons. That means we have solar cells and BFO solar system, and with this solar system, with many arrays of photovoltaic modules, we can produce electrical energy, and the electrical energy can be also brought to the end user of electrical energy. So I think, yes, I don't need to read here. I think I explained the possibilities through this diagram. So the application of solar energy and traditional, now that is especially for traditional craft centers. How can we use the solar energy? In the traditional craft centers, actually, as I said, in this case, we can use this till here, in this part, we can use the solar energy and the training centers. That means we can heat the centers, the training centers. We can provide with hot water. We can provide with cooling if you want, also through air cooling as example, or we can provide and supply the training centers with electrical energy, which can be produced through this part here. So of course, solar thermal power plants, that is a big project, which must be, of course, implemented through government. Also that is not small, that is for a big projects, but they can be also applied. Yeah, that is for big power plants in mega or in gigawatt range. But here in kilowatt or many till 100 kilowatt or so, we can actually produce such energy with photovoltaic or here solar thermal energy for heating and cooling and hot water providing in this range here. So cooling of training center, we can use as example our absorption refrigeration machines, which can be driven through solar thermal energy. Good, I think so. I said what I have to say here. Also, either we use the solar thermal energy for heating and hot water providing, or we can produce electrical energy for supplying the devices or the training centers. Now, a very important factor actually by using of solar energy is the efficiency of the solar energy. The efficiency of solar collectors, when we use the solar collectors for producing of solar thermal energy, of course, it is depending on the technology of the used collectors, which technology, whether the collectors are flat plate collector or vacuum collectors or concentrating collectors. And the other very important factor is actually the difference, temperature difference between the surface of the collector, or not only surface, but the temperature of the thermal solution in the collector, in the absorber, and the surrounding air temperature. And of course, the higher this difference is, the lower the efficiency of the collector. Yes, that is normally, as you see here for swimming pools as example. Here we have the highest efficiency because the temperature difference is very low, and that means the losses actually the losses of the collector are very low. But when we have a difference about 80 degrees centigrade, we have average efficiency by flat plate collectors about 50 or yes, in this range actually. Therefore, the effective using range of flat plate collectors still here about till about 60 degrees centigrade temperature difference between the surrounding and the absorber of the collector. And in this case, we have an efficiency about 50 or 55%. By vacuum tubes, we have higher efficiency, but as you know, the vacuum tubes are more expensive as the flat plate collectors. So, good. The installation possibilities of solar collectors, either in the off the roof or in the roof, or free standing installation. Of course, in our regions, that means in Syria and Jordan, the most possible installation is actually this part here, because the most of the ceilings are not are flat ceilings, and we have to make this free-standing installation. So I wanted to show you the possibilities of yes, the using of solar thermal collectors. That is actually the most possible and the most simple and the simplest installation of solar collector, which has so that is our solar collector, that is our tank for where we can storage the heat And in this case, the tank heat exchanger is higher than the collector, and the fluid inside the collector heats up due to solar irradiation and becomes lighter. Thus, it flows towards the tank, as you see here. That is free. That is, we name it as a free flow collector, natural circulation system. The most, or there's the second system, which is somewhat more expensive, actually, is the forced circulating system, the circulation system. In this case, we need, as you see here, pump and regulation for the system. But from the build here, we have a storage tank. That is our the customer, and that is the solar collector system here. We need here, as I said, pump and control system are required. Now I don't want to make more about solar thermal systems. As you know, that is a big area, and we cannot in 30 minutes speak about all the parts of this area. As example, producing or using the solar thermal energy for producing of cooling, or for driving of cooling machines, absorption and absorption machines, or to produce electrical energy. I left this part because it is known and it needs really more time. Therefore, I wanted only to show these two simple systems. Yes, because these two simple systems actually can be applied. These simple systems can be applied in the training centers. No? So the second part, and the most important part actually, is the producing of electrical energy with photovoltaic cells. Here, that is only a short presentation about the work principle of photovoltaic cell. It is known that when sunshine or solar radiation flows about or over solar cell. Solar cell is a semiconductor material or device, which also is a semiconductor device that converts solar energy directly into direct current electric energy, and can be considered as current source. Yes, as the photovoltaic cell can be considered as a current source. Yes, in the electrical field it is known. And the photon energy moves the freed electrons from low energy level to a higher one. And through moving of electrons from the holes, or from the negative part of the cell to the positive part, a current can be flows through the load, and we have electrical energy. We have electrification of our loads, which need electrical energy. So here is another picture which shows more simple how the energy of the photons can move the electrons to make the flow of the current possible. And of course, the usable electrons are only which can flows from the negative part of the relay to the positive silicium part in the photovoltaic cell. And there are many technologies, or there are three main technologies for producing of solar cells and solar modules. And these are actually monocrystalline, that is the most expensive technology, and of course most efficiency. Then polycrystalline also technology, and thin film or amorphous technology. And of course, the most expensive has technology has the better the efficiency than that is the monocrystalline. Then the polycrystalline is less expensive as monocrystalline, but the efficiency is also less than here. And the thin film or amorphous technology is actually the cheapest technology, but also the efficiency is the lowest. And therefore, I wanted here to show you again some parameter of these technologies. That is here monocrystalline for polycrystalline silicon. Yes, here is a description which components and which efficiency of every solar cell or every technology. And I wanted here actually that is a very explanation or illustration for these three. As you see here, monocrystalline has about 17 to 20% efficiency, polycrystalline at 13 to 16, and here amorphous or thin film is 4 to 12%. That is also temperature to range which can be used, and here output in lifetime after 25 years. That means he has a degradation of the performance of the photovoltaic cells. And here is the durability, that means the lifetime of the technology. So here again, efficiency of BEFI cells. I don't know, Dr. I can.
It is.
Well, have I to stop now, or I can make the?
It's more than 30 minutes currently.
Yes, yes. Okay, I will make.
You already exceeded your time.
Please,
German discipline now.
Okay, only this part. Also, I want only to make the efficiency to the end, and I stop then, and I can continue after the break.
The next session, yeah.
Okay, so as I said, the efficiency is as you see here, depending on the technology and on the actually type of the photovoltaic cells. And you see here, we have actually best research cells about 43. That is actually by, it is so, that is in the named constrained, also constrained photovoltaic. That is research. In the laboratory, really is here we have now about 31%, the best efficiency, the best technology. And here then we have crystalline silicon 18. Here we named that 3 layers photovoltaic cells. That is actually a very promising technology. Therefore, the research actually is very concentrated on this type here. That is a 3-layer technology, and in many countries actually there are many research efforts here in this region. So the most known technology are silicon, crystalline, silicium, monocrystalline, or polycrystalline, and they have practical efficiency between 2 or 8 here 2%. That is for organic photovoltaic. Organic photovoltaic, it is also known a field which also many research works are done here in this case, because the application is actually very wide. And the best one, as I said here, practical, the mono or polycrystalline, monocrystalline photovoltaic cells. So here's the practical according to the manufacturer, and you see here the range is between 15 to about 22 or 21%. Yes, again, that is the panels according to the photovoltaic type and or technology, and you see in all references actually they showed maximum about 24 in the best case. Yes, practical. Again here the actually I wanted only to say to show you this slide because it is interesting to see the classification of photovoltaic cells and the more generation of the photovoltaic. You see here it was at the beginning only mono or polycrystalline, then the second generation is amorphine, cadmium, copper, indium, and so. And the third, which here in this region here, gives us many research efforts actually. Yeah, the aim is to decrease the material, to decrease the costs of the system, and of course, to try to increase the efficiency. But this is limited according to the technologies. And but there are many efforts in this region, in this here, in this region here. Yes, yes, there are many going on research projects at this field. Good, good. I will stop here because the time is over. And in the next session, I will continue with the components and technical parameters of PV systems. Thank you very much for your kind listening in the first part. And if you have a question, you are welcome.
Can we leave the questions for the second session, Dr. Professor?
Yes,
with the next
of course. With pleasure, of course, with pleasure. Thank you again. Yes, and yeah, yes, my colleague, I hope my colleague, Professor Riegel is here. Professor Riegel, are you here?
Yes, I'm here.
Thank you.
I missed the time because
Yeah.
it was not Central Europe time, so sorry.
Thank you very much. Thank you very much. Good, I will make my screen free, and you can please begin with your share where I have to make it.
You need to stop share, Professor.
Yeah, stop share. Yeah, stop. Yes, yes, yeah.
Yeah.
Hey, thank you. Professor Riegel, please. Hello, Dr. Adnan.
Okay, so I will try my very best to get it run.
Sorry, you take your time. No worry, please. No worry, no worry.
I hope.
يعطيك العافية دكتور سلمان. يعطيك العافية.
الله يعافيك. شكرا.
You see something? No.
Yes, yes, we see. Yes, thank you.
But you see not the presentation mode, or?
Formula Sailing Aircraft Project.
الله يعطيك ألف عافية دكتور سلمان.
الله يعافيك. شكرا. شكرا.
عافية دكتور سلمان. شكرا كثير على المحاضرة.
أهلا وسهلا.
يعطيك العافية.
الله يعافيك. شكرا.
Oh, what a
الله يخليك. الله يسلمك.
You need to do screen sharing again.
Yes, yes. So I hope now it is in.
Yes, it is. It is very nice. Okay.
Yeah,
Okay, so welcome from my side. My name is Adrian Riegel. I'm professor at the Technical University of Applied Science, Ostwestfalia-Lippe, and I will share my experience with a project I made now in the past year with students studying engineering matters, but it was more or less a craft project. So first, maybe a bit about me. First school, college, and then no apprenticeship. That's quite unusual for a professor at the University of Applied Science. Then Army service, then I studied mechanical engineering in Karlsruhe, was a scientific assistant at Technical University of Braunschweig, made my PhD thesis in Dresden. And that's important for this project. I'm a hobby craftsman, so furniture, boats, and everything out of wood. That is my hobby. So what is our course of study? It's called Wood Engineering, and it's an academic course. Is 7 semesters, including an internship in the company. You will get, or the students will get later, a Bachelor of Engineering, and the following or different following master courses are possible. In most cases, our students have already made an apprenticeship, so they are craftsmen, and then decide to go further on to become an engineer. The aim of most students is later then a career in industry. Some of them take over then craftsmanship of the parents or something else. I will show you now. I hope that this will go on. A small video just to explain what we are doing, because that is Nobilia. That is the, I think at the moment they are the biggest kitchen producers in the world, and that is more or less the aim of our course of study. So you will see nothing to do with crafts. At the moment, a battle is running between the big kitchen producers, and you will experience some numbers in the small video.
Nobilia is Europe's largest kitchen manufacturer and the market leader in Germany. Over 3,000 kitchens leave the company every day. The secret to Nobilia's success is our 3 pillars. The first of these is the product and the quality. The second pillar is delivery date reliability. Our score is 99.8%. The third pillar, which is also important for us, is cost leadership. This means that we can offer our high quality products on the market at relatively low prices. High quality, delivery date reliability, cost leadership. To achieve this, Nobilia counts on reliable and long-standing automation partners. They guarantee maximum system availability. We place very high demands on our machine suppliers. That's because we expect high process reliability from the systems.
So just to give you an idea, what is the purpose of our, now I hope you see the presentation again. What is the purpose of our course of study? So a lot of, they have to do with chipboard and solid wood and so on, but as well I hope get a good knowledge from us in mechanical engineering, how to use this machine, how to design this machine and so on. So this is in the kitchen industry in Germany, state of the art, and that has more, I think, more to do maybe with automotive industry than the traditional craft of a cabinet maker. So this is the aim, but the students, due to the case that they are craftsmen, they like to do work with hands, and so from time to time we make then or present then projects. We do together in crafts. The idea of the Vela Cup is from Italy. It's an international student competition, and a fast dinghy has to be designed, and it's a box rule. And what is important for us is 75% renewable resources. In our case, it should be made out of wood because our students are more or less wood engineers. There are at the end different competition, a towing tank, a polar diagram, and at the end then the final regatta with students and as well a professor and a student together as a group. So this was the challenge for us. I take over this idea from Italy and say, okay, that's a pretty much nice thing for our students to build a boat completely made out of wood. with crafts, with our industrial work, and with all the knowledge we gained in the engineering part of the education. Okay, first we have to collect money. Here you see, first here, this is the team. You see here, so there was a voluntary team, 15 students, kernel team, which managed and did the main thing, and then later in the shop floor. And then a lot of classes then were used to bring in the project and split it up in different smaller projects. And so at the end, over 100 persons were then, 100 students were then at the end involved. I did that together with my colleagues, and I was coaching then at the end this project. So now about money, you see how the price of such a boat you buy on the normal market is about 25,000 euros. So we did it a little bit cheaper, but all the work we did is not counted. So at the end, it's maybe more expensive. So in this situation, special situation, Corona crisis, and so on, company or the industry is not running around. It was difficult to get material gifts as well as cash, but at the end we succeeded and the boat was built, and the students had a lot of fun. The concept for this project I did together with the students was, first, we had no chance to win the regatta. I hope that this is running. I let the video play in between, yet that you see what kind of boat we have built. So this is a plastic boat, and it's run by 2 athletes. So the idea was that we taken a existing hull. We are not naval architects, so airflow design, hydrodynamics, and so on. That's not a matter of wood engineering. So the case was that the innovation should be on other fields, and the slogan was made everything possible made out of wood, and we succeeded at the end. So that means that at the end it was an extreme lightweight construction and a good all-round behavior, because they are not the athletes normally we have. So we were quite inventive, because what we see here is the state of the art of sailing at the moment, the America's Cup. Just some months ago, it was finished and won by the New Zealand team. Here you see the Italian team, and they had also a turnable mast. Our mast was wood. This is carbon fiber, okay, and they have a double mainsail. If you are a sailor, maybe you can find it out. So the innovative level was quite high in our small project at the end, and also the craftsmanship then as well, you will see. Though the design was not made by our own, so we've taken a boat. I have such a boat as my own, and 2 students were in my garage at a very cold day in winter and take the measurements of the hull. Then at the end, we had a points cloud in Inventor, then did a 3D model, then reduced it again to 2-dimensional drafts in AutoCAD, because that is what we have traditionally right at our hands, and the students are able to design in AutoCAD. And this was then the basis for further developments, especially in the courses, in all the classes which at the end were involved, and get some ECTS points. So engineering work was done in most cases in the classes. We then developed some sort of incentives. It was planned to do it more often, but at the end it was only then, due to Corona, in 1 week in 2019. And the rest was then skipped and postponed due to Corona. That was to push the motivation for the students to do the work, because all the craftsman work was done voluntarily. And so sailing is a good push for motivation. And it was then accompanied by general physical exercises. At the end, it was a casting for the sailing crew to find out who is best maybe for the sailing crew. Yeah, here you see now the overview, some images from our shop floor. So we have different shop floor of different machines, and hand power tools were used, but as well, this was our kernel machine, the water jet cutting machine, because everything was cut out then with water jets, and at the end the frame was then glued together. Here you see the Dagger board. Also here we cutted all these experience out in at the water jet cutting machine. Then here this was allowed. Some pieces we made due to the high forces, the high load. This is again the Dagger board. No, this is the rudder, but they are made out of carbon fibers. So here vacuum pressing in lamination. Here again, you see then the hull existing, a molder, a sewing machine for veneers, and then strip plank activities, handmade for these machines with those students who were involved. Then steaming and bending, and gluing, and also sewing and welding. How this carriage was welded by our apprenticeship in cabinet, female apprentice for a cabinet maker in our shop floor. We used a box, a model to find out the ergonomics, and then which was quite often used by the students, the fixtures, the blocks, and the clues, and so on. If possible, the students used our FDM or selective laser melting machine to print it out then at the end. A lot of fixtures has to be used. You see later a lot of numbers for lines and clues and so on. These are fixtures we developed here to get the job done. Mast building was quite challenging for us, more than 8 meters long, very accurate, very thin, and and turnable. That is maybe something which is important and which was a challenge. So craftsmanship. So we have different machines in our shop floor. So a CNC router was used in 3D. Molders, lying table saw, white belt sanding machine, water jet, and laser cutting machines were used. Different power tools. And craftsmanship. So formulating two components, adhesive and gluing. So this was quite nice. Steaming and bending. Normally this is not included in our education, professional education of our students. So this was when we had to learn as well. Sanding a 3D hull so that the hull at the end is striking. So it has a nice shape. Wig welding, in sewing. We had a sewing shop floor also as well in our fab lab in Lemgo. So the sewing machine that was used and our welding was used. So a lot of we had to use a lot of craftsman devices then at the end to get the job done. Here now, this was then also a challenge because that was a master thesis work. So the beam of a sailing boat, where the sail is then horizontally fixed, this is normally made out of aluminium, and from my point of view, that's the best material you can use. But our challenge was to make out of wood. So how to produce now a perfectly tube made out of wood? So the idea was then to wrap a veneer around a kernel made out of aluminium, and you see here on the image the direction of the veneers, and this is due to the optimization in context of the tensions which are inside. I let now the video play that you see how it's made. So we've wrapped it around. So first diagonal layers to get the shear compensated, and then at the end wrapped around, glued together with epoxy resin. And this was a development of a manual manufacturing process, and the automotive industry is very interested in our developments because these wooden pipes could be used as a floor in in buses. There normally we have a plywood construction, and to make it more light, the automotive industry is looking for a replacement, a hollow system made out of wood, due to wood because it's a renewable material. Then I said, okay, that is the aim of our purpose, industrialization. And then the idea was, how can we industrialize then at the end these processes we did by hand. So here you see, because that's our educational aim, as I showed with a small video from Nobilia. So we invented here a machine which is now maybe using the process we developed it by hand, and the machine should be able, it's just a concept, so there is no funding to produce this machine, to wrap now the veneer also around, and the whole workshop was also planned by our student in master course. And what you see here in the background are machines which are designed by our students to use a special technique with a strip blank pressing a three-dimensional hull, not the complete hull, but quite not so deep shape. And this was then fixed together with a press and so on, and this can be maybe used then later to produce bathtubs or something else made out of plywood stripes, which are then fixed together with glue then later. So these kind of developments were also made in the context of this idea of building a boat for for competition. And then the boat was at the end finished, and then testing. That was quite funny. Okay, it was already Corona time, so not so funny as planned, but at the end the boat was swimming and was all right for us. Buoyancy, we had some buoyancy failures inside, misunderstanding in the design phase and so on, but that's how these projects with students are running. Then the boat was getting sails, and later it was then tested in a lake next to our university. And it's a quite fast and very good boat, good to use. So now in numbers, so 20 knots speeds, that's quite high. So that's an estimation. We have not tested, but it's faster than my boat, and my boat run at the end, if you are very clever, 30 knots. And so that is very fast. So that's challenging. That's great. You see 150 meters ropes and so on. And we have 32 square meters sail area, so it's a quite fast boat. So comparable to boats which are used then at the Olympics, quite in that area. The Olympics have even more square meter sail area, but we are next to that. What are my observations in the projects? Our students are motivated if ECTS are given. If not, so it's quite a challenging work to get the project running. So that is quite a huge factor, ECTS. If they can do the work in digital, completely digital, so 3D design and then print it out, that's great. So that is what they like. So handwork, even if they are craftsmen, so the digital work is preferred. The realization, if you have later in your hands what you have designed and you see it working, then later on a lake, that is quite a good motivation. It's an incentive for the students. The voluntary commitment was at times very poor. So I was always pushing to keep the project run, because I promised that the money I get from our sponsorship should not be wasted. The endurance in the project is limited. So if the students have the ECTS points in hands, that's it. So that is the generation of students like they are. And even the craftsmen are not so hungry for the practical work. Physical perception in motion, that's poor, because I'm still looking for a good crew to get the sailboat at the end run at the speed it is designed. the time grabber is at the end the smartphone. So there's no leisure time left. That's my observation. So because they are spent so many 6 hours per day for media consumption. So even there's only maybe 1 hour left then for practical work. What is now the outlook? There was the Polar Challenge is coming, but I get no. It's not allowed for our crew to join because our corona regulations at the university. But there will be a meeting of the German participants. We have now 3 boats existing from Karlsruhe, from Kiel, and Münster is preparing. In September, we have the cup, and we will display, as we did already in the last year, we will display on the biggest fair for boats and sailing boats and motorboats and everything, water sports, in Düsseldorf. What is also nice is that at the end, all the technologies we have developed could be used. The colleagues Neta and colleague Sachse have already had a closer look to all the things we have developed, as well as the boat, because maybe this can be used then to design the cabin of the monocap, which is quite big development at our university, together with the University of Bielefeld, the University of Applied Bielefeld. They developed a monorail railway, just using one rail, and there maybe they use all these wooden technologies we have developed. So this is what I have prepared for today. I hope I have give you an overview how these kind of projects could be integrated in our courses of engineering studies. It's a good PR activity. So we had a good press outside. You see here the last picture, the German television taking images and videos for the news in the afternoon. It was a good challenge for our students. Endurance was needed, but at the end, I'm very happy to have.
دكتور لؤي, thank you.
Thank you for your attention.
يعطيك العافية. لا ما اطلع بس احكي كلمة توجيهية وهي الدكتور بسام رئيس الجامعة بده يحيي سيمينار.
مساء الخير
أسعد الله أوقاتكم جميعا.
أهلا دكتور.
الخير. يسعدنا نلتقي فيكم ونشوفكم بهالمشروع الرائد. نتمنى لكم كل النجاح والتوفيق. نتمنى نكون معكم فنيا، ولكن ظروفنا ومشاغلنا ندعم الفريق اللي عم يشتغل معكم، وكل التوفيق لكم إن شاء الله.
شكرا دكتور، حضورك ودعمك بيشرفنا دكتور، واحنا يعني بنفسكم ان شاء الله ماشيين بهالمشروع، وان شاء الله بحقق اهدافه للاردن وسوريا باذن الله تعالى.
So if these are questions for me, I'm sorry. I understand only English, Italian, French.
Yes.
My daughter's learning Arab language, but not me.
That is good. That is good.
I'm sorry, this was an interruption from the president of Tishreen University. He wanted to encourage us for the work we are doing, and it seems to be he loved the presentation and the picture you were presenting. So it's a good bonus for our project, and thank you for your presentation.
Thank you.
Thank you very much, the colleague Riegel, and I think if you have some questions from the auditorium, you can make it. As we have some minutes, 5 minutes. If any question, you can. I think make it.
I have a question, Professor Salman.
Yes, please.
As I understood, they are engineering students.
Yes.
They have the knowledge of aerodynamics and the engineering design, but what about the crafts manufacturing process in terms of
our students?
Was there any cooperation with the master craftsmen that dealing with the work and working with traditional pots or something like that?
No, our students, normally there are craftsmen as a cabinet maker, as a carpenter. We have also one boat builder at the moment. So there, in 90% of our students are already craftsmen. They are not master in craft, but they are craftsmen. So apprenticeship is over. Then they decide to go further and say, okay, I would like to become a mechanical engineer, but not a mechanic, an engineer, a wood engineer.
Yeah.
So they are not mechanical engineers. So they have not aerodynamics. So they have not hydrodynamics. What they have is mechanical, a bit of mechanical engineering. Wood machines, for instance, they have the basics in fluid dynamics, so that at the end they are able to calculate an exhaust system for chip and dust removal and so on, but not a boat. So it's a special creation for the industry. I showed you on the small film, with a small film like Nobilia and so on. They need a lot of engineers, but not the mechanical engineers. They need a special engineer which is able to deal with the product in industrial furniture production or prefabricated housing or so on is facing. So that is what they are. That is the challenge. The boat was just coming in because the idea of the Italian idea of this challenge. And I say, okay, this is combining all the things we have. So the mechanical engineering, the craftsmen, because they are craftsmen, they like it. At the end, they have no time. But at the end, years ago, they had the time and went on with craftsmen. So that is the mixture. And my challenge, and what was very important for me, was then the combination and see how the process is running craftsmen, handicrafts, and then later how to guide this process then in an industrialization. What I did in the master courses, I showed you with the presses and the design of the wrapping machine and so on, because that is also done. The technology development is also done by our wood engineers, together then with mechanical engineers, which are then the designing the machines itself. But the process is designed by our students then, or by our alumni.
So the system is based on a project-based analysis. This is the teaching process that they have to take certain projects and they have to manufacture it and go through the whole process in terms of analyzing the materials, the design process, and manufacturing the actual pieces.
Yes, but this is at the end. I showed you the complete overview, but there were a lot of different courses inside. So this was a combination of different classes and different terms. So and not in all cases we teach project-based. The student like to have a project in the class for this specific lecture, but not in all times. But with this idea of the competition from the Italian colleagues coming inside, a lot of students had the opportunity to participate and make a small contribution only. One guy was, for instance, designing just the rudder, not more. So just the rudder, that's it. And another guy was designing the mast, but at the end he had no time, so another crew was building then the mast, and so on. So this was the combination.
Thank you very much. Dr. Salman, you are muted.
Thank you.
Your microphone.
Thank you very much again. Have you any another question to Professor Regan? Good. If so, I think we can start with.
Okay, so thank you.
Thank you very much.
Thank you.
Cheers.
Thank you. Thank you.
Thank you.
Thank you, colleague Regan. So, yes. So, yes, the next lecture is by Professor Martin Oldenburg. I hope he is by us. Martin, are you by us? I think as a colleague Martin Oldenburg actually has another workshop, another meeting, not workshop, another meeting, and I think he is now not available. Maybe, yes, Mrs. Christina Kusa, are you by us?
Yeah, Christina with us.
Christina? Yes, are you with us? Hello? I think.
So maybe if they had the same, they made the same mistake like me. So there is a time shift. Oh, that's not. It was not Middle European.
Yes, but I wrote that is
one.
This is voluntary work, you know. It's just almost completed for voluntary work. You're right.
Miss Christina, are you with us? Oh, it seems I think I showed her name, but
yeah, her name is there. Yeah, but she's muted.
Yeah. Okay, then we can we can take Mrs. Samaher Wannous. I don't know.
Yeah, this is from Tishrin University.
Yes.
Yes, hello.
Hello, you are here. Hello. Can you please start with your presentation?
Yes, of course.
Okay, thank you very much.
Thank you very much, Mr. Salman.
Thank you. So you have the screen free.
Okay. It's okay like this?
Yes,
yeah.
Thank you very much. Yes.
But can you do it slide screen, please?
Yes, just a minute. Just a minute, please. It's okay, I think.
Yeah, perfect.
Yes, thank you.
It's okay now, yes.
Okay, just a minute for me because, okay, this one. Okay. So hello everyone. My name is Samaher Wannous. I'm doctor of Tishrin University, and normally I'm with my partner, Dr. Rana Badr, but she has a meeting also today, so I will present the presentation by my own. In Tishrin University, I am the head of Department of Architectural Design, and now we will present the role of handicraft in enriching the visual sense of the heritage architecture in Syria. So in this presentation, we will talk about craft, what's craft, and then the relation between craft and architecture, and we will see the role of craft in the Syrian architectural heritage, and finally we will present a little what we are aiming in our courses in this project of HANDS. In general, craft is object made for use. The technique for creating, I hear my voice. So, the techniques of creating them were learned through family or community traditions, or occasionally through an partnership program with master artisans, and refers of manual dexterity and artistic skills required in working with materials and in creating objects that can be ornamental or functional or both together. Craft is also the development of practical, aesthetic, and thinking skills, and of creativity through the conception and production of individual works and an in-depth engagement with materials. So these are some definitions of people who interest in handicraft and craft and art and architecture. For some, craft is about making objects mostly by hand, where functional and aesthetic consideration are equally important. Many try to define craft through materials or disciplines, or a combination of the two. For example, we said wood, jewelry, furniture, weaving, ceramic, etc. Here we have an international classification of crafts. Indeed, many people prefer classifications of crafts in materials because it's more general. So we say wood crafts, stone crafts, metal crafts, etc. And there are other classifications like furniture crafts, decorative crafts, rural crafts, etc. also, and we can merge also mixed media, hobby media, folk media, etc. All these crafts, we can add also the specific of Syrian crafts and handicraft, traditional handicrafts, which I will say the names in Arabic because it's important, like ablaq, and I will explain later. Arabesque, Ajami, Kashani, stained glasses, and there is also marble, stucco panels, and calligraphy, and there are also a lot of other types, but I will explain just a little about, because we will explain the relation between handicraft and architecture in Syria and the heritage architectural, the Syrian heritage architecture in another way. So for some examples of traditional handicraft in Syria, the arabesque, which is the name given by Western, for all type of ornamented in design. And these types of decoration is divided into two major pieces, we can see. The first is geometric shapes of Islamic decoration, such as straight lines, angles, polygons, stars, etc. And the other is flowering, which is a potential form such as curved, twisted, or circular lines, or shapes of animals or birds. The other example is al-ablaq. Al-ablaq is a type of arrangement of stone, colors stone, which is like white and black, red and black, brown and red, etc. And the use of ablaq in building spread in Syria and Egypt, especially in Cairo, which was the first capital of the Mamluk state, which was known for the striped dressed stone masonry. Here we have some examples of Al-Ajami, which is a very beautiful fine art and handicraft. It's the work in wood, colored wood, and it's used in ceiling and walls and also in furniture, and it makes the interior environment like a carpet, and it's very, very magnific. We can see a lot of example in Syria, in Damascus, big houses, and in Aleppo. And this other example of Al-Kashani, which is the type of excuse me, a decorative element of colored glass coated ceramic or of brick slabs coated with a thin layer of colored Chinese clay, which is braided until the clay layer harden and become smooth and shiny. Other example of handicraft in Syria, traditional, also the stained glass windows, which we can see a lot of examples in mosques and in iglis and in other important public buildings and big houses of traditional architecture. Of course, there is a lot of examples, but I will stop here. This photo is of the Souk al-Hamidiyya, which is a traditional souk in Damascus city, an ancient souk, and it's a big storage of heritage handicraft and heritage architecture. I hope you can visit it one day, because it's really very interesting to visit, and we can have a lot of inspiration about craft and handicraft and heritage architecture and what we can do for the future. Now we will talk about the relation between architecture and craft. It's very important that we try to understand what are space-making crafts and what are space-making elements. We can say that space-making elements and space-making crafts, they together create architecture. And so they do create architecture. And when we talk about this creation, we will talk about also materials and skills and tools and technique and technology which combine to make this type of architecture that we can translate in building, furniture, object and artifacts and surface finish and surface ornamentation and hardware and accessories. So space-making elements could be referred to architecture elements and interior architecture elements that make space. Now these elements could be architectural, like floor, wall, columns, roof, etc. And it could be interior, like doors, windows, furniture, ornamental, surface finishing, colors, and etc. What we define as a space-making craft are the craft related to building, to generate and define and enhance building with materials, which is wood, stone, glass, metal, clay, etc. And again, we can say this is the classification of crafts and traditional crafts that we can merge the two materials and crafts. In Syria, for the architecture and craft in Syria, craft trade were part of the socio-economic character of major Syrian cities, and guilds had played a crucial role as channel of representation for artisans in their societies and regulated through agreement or like, therefore, their relationships to their states. In Damascus in 19th century, guild shows the essential role of master builders in regulating microplanning, working directly with residents and authority, and practicing in private or public construction. So I'll present here a very interesting study made by an Syrian architect, which name is Wassim Al-Asli. It's about craftsmanship for reconstruction, artisans shaping Syrian cities, which really explain how craftsmanship and handicrafts make the vision of heritage architecture in Syria. So in the Ottoman period, we have two leader person in the sector of construction. They were builders, master builder, and architect. Master builder is the one who solves problems, and the architect is the one who has a vision about the architect and art and the relationship between them. But in reality, the main relationship for construction, especially the vernacular construction and local construction, was between master builder and the private construction directly with the local community. And it was directed by Mimar Bashi. Mimar Bashi was the president of the Guild of Construction Buildings. So the relationship, it was very tight between them. The architect was related with the court, with the state, and he worked especially with public construction and not really in residential construction, just in big houses and important buildings. Here is 2 examples of houses in Syria, one in Aleppo and one in Damascus. And in the picture, we can see a lot of handicraft construction made by artisans and craftsmanships. There was a 2 dichotomy between the architect and builders in the history of Syria. The first one, it was at the end of the period of Ottoman Empire, where we have the architect, the modern architect who replaced the builders and the formal military. So modern architect became the formal leader of the construction and architectural work in Syria, in public and in private construction. And we still have the relation, an informal relation between builders and private construction, especially in rural places and common cities. This is the Hijaz train station in Damascus, which built in 1920, which by Fernando do Aranda, which is an Italian architect. So the architect at that period were especially Western or have studied there and have the information of Western world. So it was really changing the style of architecture, but we still have the character of heritage elements of architecture in Syria. The second dichotomy was in the period, in the colonial period, where we have the refuse of using traditional materials. Now it was by prohibiting traditional materials for new construction in Syria. And but we still have the builders working in traditional houses for restoration and guarding crafts and heritage crafts. And this is an example of Ain el-Fiji, which is a very beautiful building from the period from this period, which made by new materials, but also have the style of architecture, Syrian architecture. The greatest understanding and appreciation of heritage in the Arab world relied on the term authenticity. This understanding varied from rigid conservation in a few Arab countries like in Syria to a total liberty to demolish and reconstruct historic buildings or sites like in Gulf countries. The term authenticity was introduced in the matters of heritage, art, and architecture. So we present heritage architecture like authenticity, and it was a very important term for the architect in that period and make their own of concept. So authenticity of the buildings of this style rely, according to several Syrian reformers, on the creativity of its architects in reviving and rationalizing and reformulating local reference according to contemporary logic, spirit, and techniques. So far, the sign of the Syrian modern style reflect the belief of the owners of buildings and their architects. And For that, we can have the words of Moses, which said, "One cannot beat the intimate understanding of material process and form that comes from a craft education. All designers and architects should go through a few years of hands-on materials training. It would make them better at their job." And for that, we have in this diagram what we aim to do. So we classify different kinds of crafts: traditional crafts, heritage crafts, and handicrafts. Also studio crafts, digital crafts, contemporary crafts, which is, and these building crafts, which is largest factor of building crafts. And these building crafts then contribute in creation of architecture and interior design, which are defined through materials, different materials also, as we see before: textile craft, wood craft, earth craft, stone craft, race craft, metal, etc. We have to recognize this sector. We recognize this sector in our work and in our education, pedagogy, and our architecture practices through research, documentation, mapping, craft workshop, innovation studio, training, research, application, and resource building. So our aim in our course about design and implementation of traditional architectural elements, we aim to achieve three important things. The first, incorporate knowledge of contemporary and historical art and design theory principles and historical practice in the conceptualization and development of studio work. The second, training students to research the architectural elements that characterize local architecture and fit the social environment. The third, redesign and implement these heritage architecture elements and use them in accordance with the requirement of modern architecture. We aim to achieve this objective through 5 topics, which are traditional motifs, elements of local traditional architecture, stucco, gypsum stucco and decoration, arabesque, and finally e-marketing strategy and tools. The strategy of work is about have the analysis and historical study about each topic, and then make the research about technology and handicraft and how to make it. After that, we have the 3D model of our works, and then we will implement or reinterpret these topics in a contemporary context of design of our students. Finally, we can see here in the photo our students and assistant architect working together for and explain how we can merge handicraft and traditional crafts in new context of architecture. So thank you very much, and I'm ready if there are any question. Thank you.
Thank you very much, Dr.
Yes.
Maher.
Can I ask a question?
Yes, yes, you can ask directly, please.
Yes, thank you. I want to ask Professor that can we see in the future an organized expansion in using traditional crafts and architectural elements in future projects, or it's the time to upgrade and develop a new architectural identity based on the old traditional methods?
Yes, it's about a new vision of architecture, but our new vision of architecture just must have some history, and our history is very rich. We have a very rich history and culture, which is very, very ancient. So basing on these stories and heritage, we can reach to a new vision of architecture, and it's one side. We have a lot of type of design. So one of these is basing on a traditional architecture or traditional elements. It's not it's not the only way, but this one way we are trying to do and to work on in this period in our project of HANS. So this is.
Thank you, Dr. Sabah.
It's like because most of the projects that depend on the traditional or old styles, they are repeating the same elements again and again and again. Most of modern world repeating is boring, even if it's old thousands of years ago. The architecture, I think, have the lack of finding a new way to express the traditional heritage, the rich heritage of the country.
Okay, for me, not necessary. You can see there is a lot of very famous architects have a part of heritage architecture or heritage motif, especially Arabic motifs, geometric motifs in their architects and in their buildings, in their projects, and they make a difference. And they are very important buildings right now. And it's not repeated, it's original. So it's not really repeated what we have in past. No, it's see what we had and what we can use and what we can develop for the future. So, and if you notice in this period, there is a lot of people try to return to handmade things. So it's about nostalgia also. So I think it's very important for us to really have a good history or a good memory about our real story, for having in future our identity, for being different from others. I hope that I answer your question.
Yes, thank you. I think
yes, thank you very much.
Very important.
Thank you. Thank you.
Okay. Thank you very much.
Thank you.
Are there another or any other questions?
Yes, Uta Potkieser here. I
Yeah.
raised my hand.
Hello.
Hello. Simon Ajib, yes, hello.
Yes.
Hello.
Yes, Professor.
Yes.
Yes.
Thank you. I just joined a bit later during the last presentation of Musa Al-Samara. So I didn't hear everything, but so congratulations on your presentation. And I also like the question of Marwan Mahjouba. So I hope I pronounced correctly. Mahjouba. Because I assume you are a student, looking at your age. But I think it is interesting that you said you find it boring, or repetitive. I think the question is, what is the right criteria to judge on these things, and what is boring, or why might repetitive be good? So we should look at other aspects, like what is the function, what was the purpose maybe of these elements that are still repeated. And of course, I think one is a cultural, is the tradition, like you explained, it's part of our memory, and it's not only our individual memory, but we speak about the collective memory of a society, of a group, of a village, a family. But next to that, I think what we saw a lot in modern architecture, that they started to build something, particularly look at the Arabic Emirates, a lot of states, glass architecture, which is a bit, it's completely stupid. I mean, from a from an aspect of climate, from aspect of sustainability, of energy consumption. So there are reasons why you have certain materials historically, because they were climate adapted, they were local, and they were very well fitted to what maybe you need. So traditions also often make very much sense. And what I understand is it's architecture, interior designer is a creative discipline. So of course you want to innovate something. And I think we can find new ways of innovating by using the potential and the strong, arguments of the historic ones. And we have to be clever in adapting it to the present time, and not then repeat, maybe patterns from other regions that maybe or other times that doesn't make sense. And I think that happened too often in the past. So it's a very sensitive point that you were addressing with your question, for sure. Thank you.
Thank you very much. I'm very okay with all what you had said just now.
Thank you again.
Thank you very much.
Are there another questions? Please.
I think the Syrian architecture, traditional architecture in Syria, it's the best time. This modern days is the best time we can use our own old tradition, because we have in our tradition elements that go well with weather, elements of natural resources like stone, wood, traditional crafts, and it's a little bit sustainable, I think, if we use it the right way. So it's the best time we can use it. But what I want to ask that question as if how we can use it right. What is the boundaries that we should use it in? Like not random using our heritage so in the wrong hands.
I think the answer of this question, it needs more. I think yes, she answered you are right that we can use our tradition, our our very known culture in this in building, in handicraft, but we can create new idea, as with new ideas, not only the old ones, but we can make more initiative, more creativity. Sorry, in the in the handicrafts.
Yes, it's not about the
Yes.
morphology or the type. It's also about all techniques and technology and history and needs and why we use it, why we have it, and how it was very good for us in the past. Why not we try to adapt a new vision of these? So it's not repeated. It's not really repeated. You have really to enter in it and try to create new things, basing, not to copy the others or write the others.
I just want to add, I think it's about adapting it. And the example you showed in your last slides by using digital technologies to understand or to create and to produce also. So there is the traditional technique, but how can we combine it with new technologies? That's a very huge discussion. And I think everywhere in the world, the architecture schools and heritage institution preservation schools, they are very busy with this question. How can we make use of, for example, 3D printing for technologies that were used in a different way? And then you come into material science, because you have to modify maybe the material that was used as a handcraft and adapt it for a 3D printing process. And the other question is, what are the requirements we have in the presence? Of course, also the societies and people developed. So there are parts we like, and maybe it's the morphology and the picture, but we need maybe other requirements to come with it. And in that way, it is smoothly modified. I mean, technologies or construction methods or constructions itself. It's a process.
Yes, you
Oh, yes,
are right.
that's
Thank
right.
you.
That's right.
Yes. Okay. I think.
So, but just I am just because this is the computer of Professor Moussa Samara. I
Yes.
repeat, my name is Samaher Wannous, and
Yes.
my colleague is Dr. Rana Badr. So many thanks for the opportunity for participating with you, and it's very interesting. Thank you very much.
Thank you again very much. Thank you again, Dr. Samaher, and your team, also for your team also. And yes, maybe us in another workshops. And
I hope that.
Yes, thank you again. Thank you again. So according to the time, I think we have now a short coffee break. Please, yes, till please be exactly at 14 or by you 15 past 15, and we continue our workshop at exactly at 15:15, please. Okay, thank you, and enjoy his short break.
10 minutes break.
Okay, please, Dr. Luai.
Yeah,
okay.
Fantastic. Okay, fantastic.
Thank you.
10 minutes. Yeah.
Thank you. Till later. Yes.
Okay.
I think yes. My colleague Dr. Martin Oldenburg, he is now here, and he has joined us, and he can start with his presentation about constructed wetlands as an appropriate technology for wastewater treatment design and construction details. Martin, the floor is yours.
Yes, thank you. You can hear me and see my presentation?
Yes.
Yes, fine. So I want to make a very short lecture about constructed wetlands. Why constructed wetlands? Because also in rural areas and in area with missing infrastructure for wastewater, decentralized systems and constructed wetlands are part of a decentralized wastewater system, can be an opportunity for the wastewater treatment because it's easy to handle, it's easy to design, and it's easy to construct. And I want to give you a few construction hints and a few examples for the construction, how to deal with it. So we have different forms of organization. The most common form of organization in densely populated areas are centralized organizations. For example, for the wastewater treatment, that means we have collection areas and we have transport conveyance elements. That means pipe systems, for example, which are transporting the polluted water, means wastewater, to a wastewater treatment plant, and these to an outlet to a river or a lake or to the ocean or whatever. But this is only feasible and makes sense for really densely populated area. We have in Europe as well as in Syria and Jordan, we have more or less rural areas where we have to look for decentralized organization. And decentralized organization of for example, of wastewater treatment can either be that you have quarters or areas which are connected to wastewater treatment plants, and I have a few of them, or downsize also to property solutions where I have a wastewater treatment plant for a house or a group of houses or whatever. And we have a very strong discussion what is recommended. Is a centralized organization or is a decentralized organization? It depends ever on the boundary conditions, the local conditions we found. So the structure has to be chosen in dependency to the local conditions you find. So then you have to decide what is better to do this on a central level or on a decentralized level. And wastewater treatment is still in Europe a common problem, and we are also looking in the rural areas for appropriate technologies. And for this, I will show you the constructed wetlands. At first, what is a constructed wetland? A constructed wetland is a filter bed, mainly with sand or gravel, with plants. And this filter bed is loaded with wastewater. And during this procedure, after the loading, the wastewater is treated and can be discharged or can be used also for different purposes, like irrigation purposes, for example. And constructed wetlands, for the construction, I will give you a few slides later on. We have a filter process, and filtering is very sensitive towards particles which are carrying the risk of clogging the filter, and therefore a pre-treatment is necessary. And the pre-treatment and constructed wetland can be used for domestic wastewater, for the whole wastewater, or it can also be used for the treatment of the gray water. And gray water in this sense is the wastewater without any fecal wastewater. That means toilets and toilet systems are excluded. Both is possible. It has a dependency on the size of the unit and on the pre-treatment as well. The application of constructed wetland is not so much common in the densely populated area, but is more or less, you can even find them in Europe or also in Jordan, for example, in rural areas where, because people can do it partly by their own, they can do special types of working they can do by their own. So it's also cost saving, and therefore it's very interesting for the application there. At first, we need a pre-treatment. The pre-treatment for the wastewater is more or less more common as sedimentation tank, or often used or often named as septic tank. That means the solids can settle down, and this works as a trap for the solids. And volume for such a solid trap in form of a sedimentation tank is very important, and the volume depends on approximately 600 liters per person up to 2 cubic meters per person, and because we have to collect the sludge. And the sludge volume we are collecting is approximately, for the domestic waste matter, from at the rule of thumb, we can say approximately 500 liters per person and year. And for the gray water, it's more or less, it's only 10% of it, because when the gray water does not contain fecal matter, and so the solid is much lower, so we have less sludge. That you have to keep in mind. And these sludge volume is ruling the size of the volume tank, of the septic tank. So when you have a gray water treatment plant, you can make it much smaller than when you treat the domestic wastewater as a whole flow. But I will not put the focus on the pre-treatment. I will have a focus more or less on the constructed wetland. But nevertheless, don't forget, when you have a constructed wetland, you have to look for a proper pre-treatment which works properly to avoid the clogging of the filter bed of the constructed wetland. And the sludge here is an example. The sludge from the gray water, as an example, sediment will be collected on the bottom of the tank and can afterwards it can pumped away by a sucker that you have to do for gray water. You have to do every second, every third year. For domestic wastewater, where it's a little bit more, it's recommended to do this every year. So we have different types of constructed wetlands. We can differentiate the constructed wetlands as in free water constructed wetlands, or in horizontal flow subsurface constructed wetlands, where the water has a more or less horizontal flow direction. this is very easy to construct, and you don't need a pumping, and it's also can do it also with on a low cost range, but the effectivity in the meaning of the elimination rates or horizontal flow subsurface constructed wetland is much lower than for vertical flow subsurface constructed wetlands, and therefore they dominating now the situation. When you have constructed wetlands, you find mostly vertical flow and subsurface constructed wetlands, and with them you have a very good treatment with low costs, and in many countries we have good experience with these type of constructed wetlands. So what are characteristics of the constructed wetlands? At first, we have plants on the constructed wetland, and the plants are not really responsible for the cleaning effort. They are only doing a part because the main processes, the main biological treatment is done by the biofilm on the filter bed, but the plants support these process, and the plants as well are supporting, and also they give a nice view on it. It's a more better viewing than it's planted than without. We will see this later on the slides. We have a layer of sand or gravel, and here the tendency is now today more to go to sand, and we load this only with pre-treated wastewater. This wastewater can be domestic or grey water, as I said before. And we use mainly septic tanks. Very seldom we use very coarse filters with a very grain material, but that's not so much common. And inside of these constructed wetlands, we have an interaction of various processes, of chemical processes, of biological processes, and also physical processes like absorption processes. And this is done by the biofilm, the plants, the filter material, and the microorganisms which are part of the biofilm. And these activity of the biofilm material is important, and this biofilm is mainly fixed on the bed material, on the sand or the gravel. And also we have a little bit free microorganisms which are not working as a biofilm, but these are not, they are not playing the main role. And the other characteristic is, and that's very important, we have an intermittent loading. That's why we see later on. The size, at the moment, 1,000 people connected, which is the maximum size. There are a few constructed wetlands. They are a little bigger, but they are really extraordinary then. So here, a very simple scheme. Unfortunately, it's written in German, but that's not so much important because I explain these here in detail. So we have a bed which is sealed by a seal, and inside of the bed we have different layers. We have on the bottom we have a gravel layer, on the top we have a gravel layer, and in between we have a filter layer, and this is mainly done by sand. This filter layer is planted with plants, and we are often using reed, but you can also use pampas grass or other plants. That's not so much important. You must be aware that the plants are able to live with this fluctuating water level. And then we have a distribution pipe system. These are mainly small pipes with holes on the bottom of the pipe. So the water is pumped into this pipe system, and it's intermittent loading. That means you do it not constantly, you do it flush by flush, and the water is rinsing through this filter bed. And it's not even necessary to have a pump when you have a slope, which is quite sufficient. You can do it also by gravity, but then you need a difference in height, and that's not in every place it's the case. Therefore, we often work with electrical, very small pumps. And the water then rinses through the filter bed, and it's collected by drainage pipelines, which are on the bottom of the filter, which we can also describe as collector pipes. And then here we have the effluent pipe. And here we have our pipes on the top. These are for the aeration, because we have to aerate the filter bed, because we have aerobic microorganisms. They need oxygen for the work to degrade the organic material, the organic substances, and these aeration takes place by these aeration pipes. It's a natural aeration by convection. No artificial aeration is necessary. That's a reason why you can do this by your own. You can do the excavation by your own. You must be a little bit more experienced with the pipe, the design of the pipings and the laying of the pipings, but the filling again you can also do by their own. And the main topic is the sealing. The sealing can be done in different ways. So we have this simple system of the picture. We have the excavation, which is something around 80 to 100 centimeters in depth. We have the drainage layer where the collection of the water takes place, the collection of the treated water, which is mainly done by gravel. We have the filtration layer, which can be sand or gravel, and we have the top layer, which is also made of gravel and which is responsible to distribute the water on the whole surface of the constructed wetland. So what are design criteria? You need approximately 4 square meters per person, which is a number which is given for European conditions. In other countries where it's much warmer, you can go down to 3 square meters per person. And when you load this only with gray water, you can also reduce it down to 2 square meters per person. So this is the space you need. And we, in our German regulation, and that's also the experience, show that you have at least a minimum surface of 16 square meters. That is the smallest surface, but you can increase it with the increasing number of the population. The COD load, COD is a value for the organic matter in the wastewater, the chemical oxygen demand, should be around 20 grams per square meter a day per load, and the hydraulic load should be 80 liters per square meter a day. And because when you exceed this, there is a risk of clogging, and then is the retention time of the wastewater into the filter bed is too long, and the effectivity drops down significantly. And as I said before, we have intermittent loading. That means the infiltration time, that means the time between the 2 loadings, should be at least 6 hours. That means in average 4 loadings per day. And the filter loading during the pumping operation should be 6 liters per square meter a minute, that we have a proper flush on the surface of the pipe. And we say approximately 6 liters per square meter should be loaded per flush. And the outflow orifices of the distribution pipe should be at a minimum with a diameter of 8 millimeters, because when we have raw wastewater or raw gray water, we have also biofilms. And when you make a very small opening in the distribution pipe, that there is a risk of clogging. That means a biofilm growth takes place and closes it. Therefore, it's recommended to have an outlet of a minimum of 8 millimeters. And the area per outflow of orifice should be at least 5 square meters. And when you make more of these openings, then you can reduce the area per person, because we say then the distribution of the water is much better and we can reduce it. So the sealing of the filter bed can be done by a mineral sealing, for example, by a layer of clay that you don't pollute the groundwater. And then we have the permeability should be lower than 10 exponent minus 8 meters per second, and the mineral sealing should it be at least 30 centimeters. This is recommended when we have clay in the area, when you can have access to it, when it's cheap, then you can use this. Otherwise, you can use plastic films, which should be UV resistant, mainly done of polyethylene in a thickness of at least 1 millimeter, which should be welded to avoid any leakages into the ground. And for the filter material, we propose here, or we have good experience with one layer filter. That means with a uniform layer diameter, and the permeability of the filter layer is given here, a technical number, and it should be sandy or gravelly, and the sand diameter should be 0 to 4 millimeters, with a characteristic that the relationship between, or that the 10% of the coarse diameter should be between 0.2 and 0.4 millimeters, and the degree of irregularity, which is D60 to D10, should be lower than 5. It's a characteristic how deep or how steep the sieve line is. And the filter layer should be at least 50 centimeters, because the most active filter part is the upper part of the filter layer, because here we have most of the biofilm, and we see the most elimination rate is in the first 15 to 20 centimeters, and the rest is working as a reserve, as a reservoir, when we have, for example, shock loadings or higher loadings. So then I brought with me a few pictures. You can see here the construction of such a constructed wetland. This is the excavated area, which is a quite big plant, which is for approximately 100 populations, 100 persons. And here we have the sedimentation tank, the pumping station where the water is pumped afterwards onto the filter bed. Then after the final excavation, you could see here the construction site with the effluent pipe, which are still there. And then after installation of the plastic sealing, you can see the layer of the black plastic level, and then the drainage pipes on the bottom of this filter bed. Here the collection pipe as well with the outlet, and then it is filled with the gravel layer here. A gravel layer is a sand. A very rough sand has been chosen, and then it's filled up. Here the same. Here I've chosen this photo because here you can see the connection for the aeration pipes, the aeration outlets, and on the top of the filter material, and this is a little bit finer. Here you can see the distribution pipes, which must be horizontal, of course. And on the bottom of the pipes are the orifices to distribute the water into the filter layer. And after the finalization of the work, here you can see the small plants, which are just at the beginning of the operation. You can here see the outlet pipes, the aeration pipes, sorry. And then after a few months of operation, you can see it's the reed is really good growing, a good water supply, a good supply of nutrients, and you can see that's operating quite well. And here you can see that they don't build any fence around it, because of course you have no open water surface, because the distribution pipe here is in the top layer with the gravel. And so you don't have access to the wastewater directly, and it's also covered by the reed, so you can be safe that it's not any risk for to get infected by the people. And the question very often is, what is the odor? Is there any odor? Is there any complaints about odors? Where we have many experiences where the constructed wetlands are really just near of the houses, and you don't ever hear any complaints as long as the maintenance is done. So you have to do regular maintenance. That means you have to check that you don't have any surface water on top of the constructed wetland, and the effluent is quite working properly, and the pump is also quite working. And the effluent quality, when you start here, this is the influent water, the treatment in the constructed wetland, and the effluent quality is quite good. You can use this for irrigation purposes. You can use it for the discharge into the water bodies without any problems. And when we look now for the treatment efficiency, I have here given an example from Europe, from grey water treatment plants. You can see here the COD and the BOD load. The BOD is a blue line in the effluent. The COD is a red line in the effluent, and we have here an operation time of approximately 13 years, a very long time. So you can see starting from 2006 up to 2019. And at the beginning, the COD values are a little bit higher. And after a few years, it's really very, very low, and it's a very low discharge. Of course, in this case, it's grey water, but you have similar values also for the domestic wastewater. It depends a little bit on the load you have in your catchment area. And we have also a quite good nitrogen removal. What's not working very well is the phosphorus removal, because phosphorus needs partners for precipitation process. With this, phosphorus is very difficult to remove with constructed wetlands. Therefore, they are mainly applicated when we have a removal of the organic load, which is more or less the main topic in rural areas. And this is also done in Jordan. You have the first experience, as far as I know, that there were experiments done with constructed wetlands here in Jordan as well, in rural areas. We have a cesspit for the toilet wastewater, and the grey water is to a sedimentation tank, and then distributed here to loaded to a two-stage constructed wetland. And the removal rates are quite good. You can achieve removal rates of organic matter in form of the BOD of approximately 80 to 90%, and the same also for the COD all over the year as well, and also all over many different plants. These are results from 4 plants which has been investigated in a rural area in Jordan. And for details, you can have a look on the literature which I gave here at the end of my presentation. So as a summary, we can say that constructed wetlands are easy in construction and operation when you look on very simple rules and you train your people well. The constructed wetland are an appropriate technology in rural areas, and especially in countries with water scarcity, because the effluent quality of the water is quite good for irrigation, because nitrogen and phosphorus can work as a plant fertilizer. And it's also to do it feasible also in Jordan conditions. There were investigations about the year of the return of invest, and there it's shown that it can work also economically under these conditions as well. So then I would say thank you for your attention, and feel free, don't hesitate to ask questions.
Yes.
Yes.
Simon?
I have a question, please. Yes. Sorry. Yes. Thank you, Martin, for the interesting presentation. Actually, that is presentation. My question, how often must be the maintenance of such system? And if some tubes are get defect, what can we do?
So the main question is the pre-treatment. When the pre-treatment is designed properly, you can operate these units for years. Like you can see, the longest experience we have with constructed wetlands is up to 30 years.
Oh.
You have not to remove the filter material because there is a balance of growth and decay in the filter material. Yeah, we have, of course, you have a growth of organisms, but you have in parallel, you have decay as well. And the size is when the balance. Yeah. As far as a pre-treatment works properly, we had experience with a non very well operated pre-treatment. They have not made the sludge removal from the septic tank over years. Then you have solids on the constructed wetland, and then you have clogging on the constructed wetland. That's not so bad, because then you remove the first 10 centimeters of the top layer, wash it, and can bring it back. But it's only just in emergency cases, because normally when the pre-treatment, the sedimentation work is tank is worked properly and desludged, then it will work for years.
Okay, thank you very much.
Of course, you have the typical maintenance. You have to look that the pump is running, that the sludge level in the septic tank is not too high, but that's obvious.
Yes, that is normal by every plant, actually.
Yeah.
So, yes.
Okay, then I take over now the moderation from the rest of the of our workshop today. I don't know if everybody knows me. I'm Sabine Broklaus from the THOWL, working with Salman Ajib in our part of the HANDS project. So if there are no further questions, I would like to give the floor to our next presenter. This is Christine Kusa from also I think working in the THOWL currently with Professor Pottgieser, if I'm right. It would be nice if you can introduce yourself, because I didn't receive a CV or short CV from you, so it's maybe the best if you say some words about yourself and your CV, and then start your talk.
Okay.
Thank you.
Thank you.
Please, Ms. Kusa, you can please start with your talk and give a short introduction to yourself. Or can you can you share your presentation by yourself, or do we have to do something?
I can share my screen.
Try again. I think now you can.
Okay. Yes. Yes. Hello, everybody. I would like to start by introducing myself. My name is Christine Kusa, originally from Syria. I obtained a bachelor's degree in architecture at the University of Syria, and a master's degree in rehabilitation of historical and Islamic conceptuality. Currently, I am.
Yeah, you have to get close to the micro, otherwise your voice is lost.
Yeah, it's better like this, or okay. Yes, currently I am a PhD student at the Faculty of Architecture and the Built Environment, TU Delft University of Technology, the Netherlands, in cooperation with the HVL University of Applied Science and Arts in Germany. My PhD research is supported by Katholische Akademische Ausländerdienst and Gerhard Henkel Stiftung Partnerei in Germany. My presentation today is part of my PhD research, which aims to develop a conservation management plan to allow for the sustainable recovery and reconstruction of post-Syrian civil war residential building and quarters, and to propose to foster and understanding of residential heritage as part of the border system, which intend to develop sustainable cities and communities in line with the UNESCO Sustainable Development Goals, SDGs, particularly with Goal 11, to make cities and human settlement inclusive, safe, resilient, and sustainable. Also, Goal 8, to connect to our workshop today, Goal 8 seeks to promote sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work for all. Decent work priority are also included in other goals, as technical and vocational skills are covered under Goal 4 on education. So traditional craftsmanship is perhaps the most tangible manifestation of intangible cultural heritage. And one way to understand the intangible cultural exemplified in craft is to look at the tangible handcraft. Thus, the skills, techniques, and knowledge are very important for ongoing production from one generation to other. Especially in times of crisis, when natural disaster and man-made disasters destroy and threat much tangible and intangible cultural heritage, such as building typology, skills, handicraft tradition, social relationship, and so on. Unfortunately, oftentimes post-disaster intervention have not only failed to protect cultural heritage, but have contributed to their destruction. For example, a common failure is a refusal to support the repair and reconstruction of traditional vernacular housing. This housing represents not only built heritage, but a way of life, encompassing traditional building skill. Instead, generic housing have been imposed that don't address the need of local inhabitants. It's also resulting in disappearance of traditional building skill and knowledge. It's important to remember that traditional construction methods and materials are very useful in preserving the identity of a place, as well as keeping all traditional building technique alive. And the use of this technique in applied projects is like a school that enables the young generation to learn these skills and gain direct knowledge from technicians and craftsmen. Despite the variety and multiplicity of handicraft, there are a few trades and professions that are especially and closely linked to urbanization and its various branches, the most important of which are building, craft, carpentry, blacksmithing, and decoration, which encompass several complementary crafts. The connection starts with the planning of the residential area, continues through construction work, and culminate in the attention to paint and decoration. And this craft played a significant role in defining the old Aleppo city urban identity. It's worth noting that Aleppo's wealth of limestone enabled its residents to develop advanced scale in stone engraving and decoration. Aleppian limestone, which is available in Aleppo, was regarded as the best stone for carving because of its long-lasting hardness, which is gained over time. And this Aleppian artist culminated in the 12th century with the invention and use of al-muqarnasat. Unfortunately, in the summer 2012, the Syrian civil war escalated in Aleppo. This made it one of the most heavily damaged cities in Syria, with about 30% of its building completely destroyed and a huge amount of debris generated, and resulted in the city being placed on the list of World Heritage in danger in 2013. In addition to that, most of the inhabitants of the old city were forced to leave their houses and relocated somewhere else in or outside the city. As a result, many obstacles and restrictions, such as a lack of qualified labor and also a lack of education and training facilities, are leading to more traditional heritage setback. I want today to highlight the importance of material reuse. Also, the reuse of debris has not become really in Syria. Except in some recently initiated pilot projects, the reuse of building elements and recycling materials are not new ideas. For the earliest days of large-scale masonry construction in ancient Egypt, Greece, and Rome, stone has been reused many times as buildings were destroyed by earthquake or in war, or simply fell into disrepair. The manpower needed and the cost of reusing stone was much less than using a new stone from distant quarries. Material reuse may as well serve as a means of sustaining heritage value inherent in the building to the material reclaimed from them. It can enable something of value to be recovered from the West Stem. Considering the massive structural of the traditional building in the old city of Aleppo, most of the debris that has accumulated in old Aleppo city will be stone, wood, metal, as well as soil, which was used as isolation and filler between walls and the roof. In the old Aleppo city, activities to support the preservation of debris and urban historic fabric are still limited to emergency measures for the early recovery phase. In parallel with the damage assessment, debris removal is being carried out in four phases. Yes, so most stone have been kept in place with the aim of recovering and reconstructing old buildings in the historical city center using historical material in order to preserve the city's identity and cultural heritage. In contrast, in Aleppo, the strategy of debris preservation has already begun, though it's largely limited to one iconic historic building where a buffer zone has been imposed around it that cannot be passed by. This means that building debris cannot be tampered with, and original building material can be extracted from the debris. It's one of the most important religious archaeological sites in the city and being rebuilt using anastylosis technique as a reconstruction technique, which is an archaeological term for a reconstruction technique in which a ruined building or monument is restored using the original architectural element to the greatest degree possible. So collecting salvaged material for reuse requires the material be accumulated at specified points and separate according to the type and usability. In this context, I have proposed a temporary open spaces site in the old city of Aleppo in order to store material until it can be recycled and reused for old and new building and infrastructure. It will be also enable treatment to be studied involving minimal intervention, retaining structural integrity, and integrating a new object and technology. I will refer to scenario 1, which is transformation of destroyed sites into multi-purpose public spaces, including damaged waste management zone and parks, which would provide a dynamic public space that fosters socio-cultural interaction and promote the involvement of residents into preserving the cultural heritage while meeting the need of a playground and recreational area. The scenario 2 is talking about transformation of components of destroyed historic building into new components and building. The reuse of building waste doesn't require complex technology or equipment. It merely requires manual labor or simple tools. As such, reuse is the simplest and most effective way of restoring historical building. Moreover, the use of salvaged material in a new construction not only saves money, but also protects land resource and transfers value attributes of historic building to the new one. Finally, with the aim of rebuilding the city from inside, recycling operation on or as close as possible to the relevant site, sorting, citation and place of use, as well as a small mobile recycling plant could be set up at the proposed site. They would process the demolition waste of the old city of Aleppo and transform it into usable material. This would also ensure a local job opportunity while providing a platform for creating awareness among inhabitants regarding the importance of their engagement and for preserving the identity of the city. Thank you.
Thank you very much.
Yes, thank you very much, Ms. Kusa. Are there any questions for this talk?
Yeah, I have a question.
Please, Monsieur.
The property of these destroyed buildings, is it public or private?
Yeah, of course, it would be public. It would be like 100 between 80 and 100% damage, and we will take into account the previous use, the heritage value, and also the ownership.
All these traditional houses, they were a public property, they're not private property?
It's like private, and some of them are belonging to Al-Awqaf ministry.
Oh, I see. So people were renting these houses, they were not owning these houses?
No, part of them, like there is like an owner and there is like a renter, or people who paid like an amount of money and occupied the house, but the ownership, it belongs to Al-Awqaf.
Is there any idea of rebuilding these traditional houses, bringing the traditional knowledge, or just completely do a modern transformation, like what example, what has been done in Bab al-Faraj? Is this the model that's going to be happening in the rest of the traditional zone?
No, of course not. My idea is to rebuild the housing as it was, to respect the heritage value. But of course, I try to come up with guidelines to develop this house to make it like more comfortable to the inhabitants. In line with sustainability. As we know, there is like a lot of guidelines which define like specific elements that we can add to the house in 1919. I think this is based on Venice chart 1964. So I think it's very old. So my aim is to develop this guideline. But of course, like the heritage value will be like respectable.
It's just a question. What happened with the traditional souk? has it been completely damaged, or it is still as it was?
Yes, it's almost completely damaged, but a few months ago they finished Al-Saqatiya Souk, Aga Khan Trust for Development Organization was funding the project, and they finished the project like a few months ago. And also there is like Khan Al-Harir Souk, I think now in progress. Yesterday they start to working with like third souk, I think Al-Hatab. I am not sure about the name, but yeah, but also with the Aga Khan funding.
Yeah, unfortunately, it seems to be that most of the traditional buildings were totally destroyed. But the good thing that we have a record of all the houses, the souks of Halab. So if they want to reconstruct it, there is original drawings that they can start with.
Actually, not really to all of them, especially in terms of housing. So also we are now working on the documentation housing within the framework of projects between THOWL in Germany and Aleppo University. We were working with a student to document 3 quarters, Al-Aqaba neighborhood, Al-Farafira neighborhood, and Al-Jalloum neighborhood. So in order to like provide a database if we want to reconstruct in future. But for example, like a monument or like most important building in Aleppo city, yes. They were documented before, especially by GTZ in Almania, in Germany, in 1992. There was a project for rehabilitation of the old city and come up with like development plan.
Thank you very much, and good luck for your study.
Thank you.
Thank you.
So then I think we should go to the next talk. Change to the next talk. The next talk is given by Mrs. Sarah Parhon. I think you're there. The title of your talk will be Sustainable Landscape Architecture, Integrated Ecological Criteria in the Object-Related Planning Process of Landscape Architecture.
Yeah. So can I share my screen and then I will introduce myself? Can you
see it?
Yes, we can see.
Okay. So hello everyone. I am Sarah Parhon. I come from Iran. In Iran, I studied Bachelor and Master of Architecture, and then I continued my education here in Germany in Höxter. Of Master of Science of Landscape Architecture. And today I want to talk about my subject. It's about sustainable landscape architecture, and actually it's about the path I did from master to PhD. So at first I will say some information as an introduction, and then about sustainable landscape architecture and some methods for my master, and the methods that I will do in PhD. For the connection of my subject and the subject of this workshop about handicrafts and art in general, I can say that landscape architecture or gardening is a kind of art, and it's a connection between human and nature. So, and I cannot see my screen. Okay, sorry. And if we see the traditional, especially if we see the traditional gardens or the gardens which are built in a traditional way. Maybe we can see more sense or more relationship to this soul of the human. For example, Persian gardens or other traditional gardens on all of the world, or for example, the Alfabia gardens in Mallorca, which is built by, I think, by an Arab landscape architect. So you can see maybe more connection between the human and nature. And we should also know that work with nature, like working in a garden, it's not like building a project like in architecture or so, and then it's finished. No, it's like a process, and it needs maintenance, and we have to keep care of it. So if we want to be more scientific, we should know that it should be also sustainable. And I will tell you why in next slides. It's because of protecting our environment and also to have sustainable ecological parameters and indicators in our environment. And especially for the 5 main environmental assets like climate, water, soil, flora, and fauna. But in modern landscaping, maybe in somewhere, not all of the projects, but maybe they just focus on functions, and maybe we have the lack of this relationship to the nature. And as you can see, and they are absolutely so beautiful, but just to have some background to go to next step, I should talk about them. And here I have some examples like Super Clean Urban Park project in Copenhagen in Denmark, or Hafen City public space in Hamburg, and also the project of West 8 in Rotterdam. They are just some examples. And then here this question comes that can we find a way in between, not so traditional, not so modern or so, and in contemporary gardens, maybe like, for example, Alfabia, we can see this connection, and how can we integrate this new or modern landscaping or gardening into our lives, like past with more essence of life. The reason that I talked about sustainability was because, okay, at first we should know that sustainability is about 3 main pillars, like economic, social, and environment. And landscape architecture as a field that has a direct connection to environment, so we can say it has also the direct direction to a pillar of environment or environmental sustainability. You can see here my mind map for my master thesis, and here in can you see my mouse? I think, okay. And also you can you should know that every product, also in handicraft, every product and every process of producing, it has a life cycle. That means we need materials, raw materials, and then it goes to processing of manufacturing, and then we can operate it and use it, and after that we have end of life and recycling. If a product, it doesn't matter if it's landscape architecture process, especially in construction, I mean, or in an art for handicraft or creating something. If the process of it comes to this cycle and complete this cycle, so it could be sustainable. And because of that, we can protect our environment, and we have less environmental impacts and these things that I will explain it later. But also this process have some environmental impact factor like carbon footprint that I focused on in my master thesis because there was no long time. And that was just as a background for my path to PhD that I decided to work on more indicators. And just one slide more about to say why sustainability is so important is, as you can see, sustainability criteria has so many parts, and a quarter part of it belongs to ecological quality. So it is exactly the quality that I'm talking in landscape architecture. And even ecological quality have some subsections like water, soil, energy, using materials, biodiversity, vegetation, and so on. I worked on CO2 neutral landscape architecture on master, and I will work on sustainable landscape architecture and to be more detailed on integration of ecological criteria for the object-related planning process of landscape architecture. So after knowing this brief background, you can see here two figures. The figures above was the way or the reason that I choose this subject or this indicator to work on, and the shape at the bottom, it's for PhD in more general way. As you know, increasing greenhouse gases, especially CO2, it will cause greenhouse effects and global warming, and we have more than 6 centigrade global warming and increasing the temperature in our planet. So it causes climate change, and climate change causes many problems in our nature and in our environment, for people, for vegetation, for animals, and so on. But in 30 years later, we should keep this temperature under 2 centigrade, because else we face so many problems in our environment. One thing that we can do is reducing CO2 in these 30 years. But why and how is the connection between this theme in landscape architecture? Is because that 40% of greenhouse gases emissions is because of construction industry, and it's a very huge amount. But landscape architecture is like a greening part of these sections, and we as landscape architects have this responsibility to reduce it and to preserve our nature. But if I want to see it now more general, I can say beside global problems, we have also local problems, and that you can see in other flu for PhD. And if you search more, or for example, read the book of Limit to Growth, you can see that because of that, it was also predicted that because of increasing in population, because of resources consumption, we have now these problems because this resource consumptions has environmental impact, and because of that we have climate change and so on. And the urbans are the important place to that these things happens in them, because for example more than 50% of population all around the world nowadays live in a city, and this proportion goes to more than 60 and close to 70% in just 30 years. And we should know that 75% of resource consumption belongs to the cities and the population who lives in the cities. So we should do something with our ecological parameter and ecological quality. And as a landscape architect, we can do something in our decision-making process for our planning to have sustainability, to have less ecological problems and better environment. To do this, I should say at first that there are so many rating systems, and nationally and internationally in Germany and all over the world, that they measure the sustainability of a project. For example, in Germany, we have BNB AA, it's an evaluation criteria for outdoor facilities, or German Sustainable Building Council, or FLL, or Seal of Quality for Sustainable Housing, and also ENVIMET is for climate simulation. And internationally, we have BREEAM, it's Building Research Establishment Environmental Assessment Methodology, and I think it belongs to UK. And then we have SBET tools, and I think it's from Canada, if I say it right. And EPA, it's Environmental Protection Agency of United States. And LEED also US Green Building Council, and SITE. If I want to say it's briefly how they work or what they do, I should say that they consider environmental indicators and environmental resources and impacts. For example, for a process, we have input like energy, water, material, and we have output. So this has a kind of life cycle. And when we assess this life cycle, and if they are in, for example, in golden range, not silver range, so it's more sustainable. And also, we should consider the effects and the impacts of these indicators on other criteria like climate, water, soil, flora, fauna, and each of them has also some subsections like global warming potential, CO2 acidification potential, and so on. There are also some softwares, for example, GreenPass, I think it's in Austria, and they measure just some indicators, not all of the indicators of sustainability. Like just climate, water, air, biodiversity, energy, and costs in 4 steps. And also green scenario, Ramboll, from the film Ramboll. And they can, in 3 steps, give you analyzed, planned, and the best scenario for your plan to have the least, for example, impact on the environment. Another software is Pathfinder, called Pathfinder, which is developed by American Society, by ASLA, American Society Landscape Architects. And You can find it in a Climate Positive Design website. It will help you to calculate your the CO2 or carbon dioxide of your project. But what is the advantage if I know how much I have carbon dioxide? In this figure, you can see at first when you start to build your project, because of that life cycle assessment and the environmental impact factor that I told you at the first slides, you have here the emitted carbon dioxide, but you have also nature and you have also greenery areas in your project, and because of them, and for example here you can see they can sink it and absorb it, and after some years you can say, okay, the emitted carbon is lower than sequestered carbon, so in this year called a climate positive year, and this and by using this free application or software, you can see how long does it take to have your the climate positive year of your project. And also there are some guidance to have less carbon dioxide and so on. So I use this application for my master thesis and for calculating carbon, but for carbon dioxide neutrality, at first you should know that we need carbon calculation. But why? Because as Pamela Conrad, the head of this, or the member of, or the founder of this application said, at first we should measure and then we can manage. And landscape architect is also not just like a field that we can absorb the carbon, but also not just to decrease carbon, but also absorb it and have something like climate positive year and more sequestered carbon than emitted carbon. After calculating carbon, then it's the turn of carbon reduction, and after that carbon offsetting. That I will tell you what do they mean. So carbon calculation and carbon calculators are existing for so many industries, like individual, small businesses, products, and also landscape architecture project. If you, and it works for some kind of projects like parks, gardens, plaza, and so on. And they said, for example, the best climate positive year for a park could be 5 or should be 5 years. But if we have plaza, when it goes to 20 years, it's also okay. The three main parameters that they consider are materials, plants, and maintenance. You can, for example, here you can see, you can enter the exact amount of your materials, like paving, walls, and so on, and also the plants and the different kinds of plants that you have, or lawns, and also the maintenance, because these plants need also maintenance, and it takes it consumes energy, and so they calculate all of them, and then you have the climate positive year of your project. And if you change something in your project, you can see if it goes up or down, then you have better situation by your project. So for my master thesis, I developed 4 kinds of sites or plant sites. And the first variant and the fourth one is like Sural, because here we have just paved pedestrian concrete, just 5 trees. And the fourth variant is also Sural with so many plants and trees. But the second one and the third one are more real. The 3 places were selected because here we have 3 kinds of climate zones, and we wanted to know if we have the same project with same characteristics, so but in different climate zones and features. So what will be the results? At the end, I had maybe more than 20 diagrams, but here you can see the end result for climate positive year. I'm not gonna talk about first version because that was also, you can see it's, we should wait 313 years to have CO2 neutral year, but the second, third, and fourth one are more real, and the difference were because of infrastructure, for example, or the types of trees that we have. For example, in Norway, more evergreen trees, they need more water, for example, or the worse situation of soil and water in Italy, or because of so many reasons, we got these results. After calculating the carbon of your project, so it needs to be reduced, and after that you can offset it. But what does it mean? What's the meaning of carbon offsetting? That means you can buy a project, buy an environmental friendly project somewhere else and invest your money on it to make up your carbon, your emitted carbon. For example, you can in this project of solar system, you can for 1 year, or I don't know, for some months, you can invest, and then you will make up the emitted carbon of your project. But if I want to say it short, I can say for carbon neutrality, especially in 30 years, at first we should utilize 100% of renewable energy to reduce the demand for energy, and also utilization of technologies through renewable energy to achieve negative emission and not always emitted footprints. So that was just like a background for my PhD, and I will work on more ecological indicators. And it has also 4 steps. At first, I should sort and classify the ecological structure types of object-related landscape architecture. It means not only object-related, but also space-related. And at last, maybe we can conclude that in different structure types of a city, as you can see here, they are structure types of Berlin. Maybe we can have a general results also for same structure types in a city. And then I should evaluate all of the ecological criteria from different assessment systems like EPD, like environmental production declaration, which is about life cycle assessment, but for materials, but we have the lack of these kind of strategies for example, vegetation and for trees, for not just only for materials. We need to connect it also to the nature. And then we can generate it as a general data that landscape architects can use, and then apply it to a planning process and to a for example, exemplary spatial analysis to have the result of the process of decision making of architecture, which should be done better by considering ecological indicators, and also on 5 important environmental assets like climate, soil, water, flora, and fauna. And to relate all of these things to my first slide, you can see, for example, here you can see some examples from climate positive design groups of ASLA. If we have data analyzed, if we have, if we consider more environmental parameters in our decision making, in our decision for our planning, so then we can see the better results that our project have on and the better impacts that our project have on the nature. And maybe something like this, to have also this traditional essence in our planning to connect the nature and human sense or soul again. And there are my references, and thank you for your listening.
Thank you very much.
You're welcome.
I have a question. Yes, what kind of softwares you are always using for data analysis?
Sorry, again, please.
What kind of computer softwares you were using for data analysis in terms of carbon dioxide and the environmental systems?
For master or for PhD, you mean?
PhD.
Yeah, it's so many indicators, and we are now on a process to limit it because I cannot focus on every indicators, but yeah, as I said, soil, water, for example, for water, we have runoff parameter, we have storm water, we have, or for climate, we have CO2, ozone, and other characteristics. I mean, I should, and it is also another critique that do we need all of them really? For example, ozone parameter, do we need it, or just CO2 is enough? Or it's the thing that I should research in the future. Now maybe I cannot say some with certainly feeling.
Yeah, maybe we need complicated softwares to gather all these data and put the analysis in a parametric way to see which is actually the most important factors and which is factors that doesn't matter a lot in terms of environmental landscaping in urban situation.
Exactly. Yeah, and we have lack of considering some indicators in the software that I mentioned. For example, green scenario or green path, they don't, or green scenario, I can say, they don't consider soil, and it's also in their future plan. What should we do with soil and with animals? So many systems, they just didn't see animals and just maybe vegetation and not. And yeah, it's the thing that I should develop or improve them maybe. Yeah, please.
Thank you for a very nice presentation, Ms. Pohn.
Thank you.
Just a short question. Why did you pick Trondheim as a study site?
Why did I pick
Trondheim in Norway as a study site?
So it's, I just look at the climate zone of Europe, and of course I wanted to have 3 different climate zones. So in Italy or in South Europe, we have warmer climate, and then in between I thought maybe Höxter that I live now, it's better, and somewhere in North, I mean, it could be also Finland or something like that. But yeah, just I wanted just to have different results in different climate zones.
Mm-hmm. Do you know any people there?
No.
Okay. Maybe if you need someone there, you can ask me.
Oh, thank you. Thank you.
Okay, other further questions?
Yes, and yes, short question before my presentation because the time about the 3 climate zones. Have you results about the different, actually the impact of CO2 emissions and the impact of the different climate zones? Have you about these 3?
Yeah, at the end, it was concluded that it's not only related to climate zones, because each country has also infrastructure. For example, in Germany, the better infrastructure or the better transporting I mean, for example, in Italy, when we want to choose a material, maybe there is not existing this material, so we have transported. And this transport has also CO2 emission. But if we have this material in Germany, so this would be deleted. And it depends on so many indicators, not just climate zones, but yeah, infrastructure, the soil activity, water availability, and yeah.
Okay. Okay, thank you.
Thank you.
So. Good.
Yes.
Good. Thank you very much for all presenters. Also, I think I can begin with my presentation.
Yeah.
Sabina?
Remember, you have to finish before 5.
Yeah, because I will try to make
to catch the next meeting.
Yes, quickly. I will try to make it quickly. Yes. Okay. So I take my. So, I think we were here. Yes. So I welcome you again to my presentation about the possibilities of using of solar energy in handicraft or training centers. And yeah, Miss. No. Okay. I present. What is, okay. What is this? Okay, the components and the technical parameters of the PV systems. As you see here, we have solar panels, also from solar cells, solar modules, solar panel, and solar system. And of course, for this system, we need alternating also isolator, inverter, battery, charge control, generation meter, direct current isolator, switch or switch device, cabling, mounting, and the tracking system if it is needed. Here, that is the summary of the components. As you see here, the main thing or the main device is, of course, the PV arrays. And then we have DC isolator. Then we have the DC to AC, also direct current to alternating current inverter. And then again isolator. We have here a consumer unit. That means, yes, that is loads, as we can here amount, or we can measure the energy which can be supplied or feed to the net, or we can also measure the energy which we have to take from the network, public network, and that is actually the main components of the on-grid PV system. Of course, if we want to storage the energy also in a battery, we have to have a battery system and control system for charging of the battery and for control the charging or recharging. So that is only a system which can actually work as standalone, but as you see here, we have a measuring system here for the energy supplied to the network, or the energy which we can take from the network if the system, if the solar system, or if the energy produced from the solar system not enough to supply all the loads in the house or in the object. So now, which technical data or technical parameter of PV system are important and are to be considered by designing and sizing of the system? Actually, the main technical data are the open circuit voltage, the short circuit current, the maximum power point power, and the fill factor of the cells. And this fill factor actually is defined in the equations, that is the multiply also the voltage at the maximum power point, multiply with the current at the maximal power point, over the product of short circuit of the cell, multiply with the open circuit voltage of the circuit. And of course, the higher this fill factor is, the better works the cell or the system. So, and of course, there are many factors which influence the possible power, maximal power point, maximal power which we can take from the solar cell or the solar module or the system. And the main influence factor in beside the solar radiation is actually the temperature, the work temperature of the module. And as you see here, also the peak power point of the module is defined under standard conditions. Standard conditions, that means solar radiation of 1000 watt per square meter, a temperature of 25 degrees centigrade, and air mass of 1.5. And you see here, when the temperature increased or is more than the standard temperature, the power will be decreased, as you see here. Of course, the voltage will be decreased with a temperature coefficient, and the current will increase, but the increasing factor of the current is about 10 folder less than the decreasing factor of the voltage. Therefore the factor of the temperature factor of the power will be decreased, and this decreasing can we show here in these diagrams. As you see here, when the work temperature or the operating temperature of the cell or module is higher than 25 degrees centigrade, the power will be decreased. And when the temperature are lower than 25, the possible maximum power of the cell can be increased, as you see here. Yes, that is here by 0 degrees centigrade, as you see here, and here by 5 or yes, minus. That is minus 25 degrees, and here is 0 degrees centigrade. So as I said, the lower the solar cell temperature, the higher is the maximal power point of the solar cell. So that here in this table, you see the range of the efficiency of solar cells or solar panels. That is 2020 actually is very updated, and that is depending on the technology and the manufacturer, but the range is between, as you see here, 19.6% to 22.60%. That is depending, as I said, on the module and on the manufacturer, which they have better or less better photovoltaic modules. But that is also, you see here, the power of one module. Yes, also that is also in average from 330 watt to 400 watt per module. So now, how can we design? How can we design a photovoltaic system? You know, there are two possibilities. Either we can design the system as standalone system or as a grid connected system. Because a grid connected system is very generally, I will make an example for the possibility of standalone system. In this case, we have to consider maybe 5 steps to design the system and to size the needed photovoltaic modules. Of course, there are many software programs which can be take as help for this aim. The most used software program here in Germany is BV Joule. There are many versions, as the newest is BV Joule Premium. And actually, with this software program, one can design either standalone systems or grid-connected system. So, by designing the system, we have to, as stand-up, we have to consider the following steps. The first step, calculation of the total amount of electricity required in an average day. How we assume for one home or sun supplied house, we have a refrigerator, we have a TV, and television, we have washing machine, we have another devices. That means we have to calculate the needed energy for the household or for the object in kilowatt hour per day. The second step is to know how is the daily solar radiation for the location of the object. Of course, you know, every location or region has another solar radiation, another amount or availability of solar radiation. Therefore, we have to consider this fact, and we have to consider the tiled angle of the system which we want to install. Yes, that means normally, as I said, we have, by designing the system, we have to consider the months with the lowest solar radiation. In this case, we are we can guarantee the security of supplying of the object with solar energy. Therefore, we take the solar radiation in the lowest amount in the year. That means in the month, as example, in December is here in Germany at least, the lowest solar radiation is in December. I think also in Syria and Jordan, the same. December is more coldest or less, yes, the lowest solar radiation is in December. So now we can calculate the related peak power of the PV arrays under considering this equation. This is here 1 plus security factor or reserve factor, mostly is 50%, multiply with the needed energy for the load for months. Also for 1 month, that means the months with lowest solar radiation in the year, in the region, of course, divided over the performance ratio of the solar system. Performance ratio is a factor which consider many factors, many influence losses factors. As example, the dirty on the surface of the photovoltaic or PV system, the losses in the connecting of the system with the inverter. Therefore, this performance ratio is about or in the range of 60 to 80%, and the lowest value actually is in regions where is many dirty at the surface, or there can be comes to the surface of the photovoltaic modules. In this case, the performance of the modules will be reduced, and the highest factor, or that is only actually suggestion or measured ranges here in 80% in regions where many rains days in the year, because they can clean actually the outer surface of the modules. In this case, the performance ratio can be higher. So then multiply with standard solar radiation as 1,000 watt per square meter over the solar radiation availability in the considered months, yes, in kilowatt hour per square meter. The first step, we have to decide how many days we want to supply with the battery, also as storage battery. And when we know how many days, we can, in the fifth step, calculate the required capacity of the battery. And this can be calculated through this equation, that is 2 multiply with the demand of energy in the considered months, and 2 here, the factor 2 actually, because as you know, we cannot discharge the battery, the maximum discharging possibility or the percentage is only till 50%. Therefore, we have to have the double of the needed energy here, or the energy demand, divided over the battery voltage, multiply with the days, how many days must the battery supply the load over the days, or the number of the days of the month. Also here I consider it December, and therefore 31 days. So as I said, the voltage of the battery in volt, and they reserve the number of the days which must be considered for supplying with the storage energy from the battery in the considered months. So this here is an example. Sorry, it is in German, but that is no problem. A small object for the demand is only 30 watt. That is for here Ferian houses. That is a home for a small home. Actually, in garden, as example, it must be supplied with energy 5 hours per day, and we have here to calculate the needed energy and the needed capacity, and also firstly the needed power for the solar system, and the needed capacity, battery capacity, when we assume that the battery voltage is 12 volt. So we only need to apply the given equations. Here we calculate the needed the energy demand, that is 31 day multiply with 3 watt, that is needed, multiply with 5 hours per day. Yes, and then we have how many how big must the energy demand, and then we can calculate the needed power. Peak is about here 2 or 270 watt, and then we can calculate the needed battery capacity. Here we have 100 ampere hours. So of course we can also calculate the system with which is connected, as grid connected. We can calculate the power of the system according to this equation, that is system efficiency, photovoltaic efficiency, that is the available area of the module, and this is here the maximum solar radiation, 1000 watt per square meter, and then we can calculate the ideal gain of this system is equal to this power as B V photovoltaic multiply with the solar radiation availability in the given region, and then we can calculate the real solar gain, also energy gain from the system, under considering the performance ratio of the system, and then at the end we can calculate the specific work of the or specific performance actually of the system, of the PV system, according to this equation, that is the real energy gain of the system over the designed maximum power, the maximum power from at the peak condition, or that means at the standard conditions. And this value here is very important to show us how many hours per year can the system effectively in full load works. That means when we here, of course, we have an example, but according to the time, I don't want to make more. When this value is 1,000 hours per year, that means our system has worked 1,000 hours with the maximum power here. That means with power peak, maximum power, which is designed to give this power. So, of course, it's belong to the system, the inverter, and here I showed you, or I will show you some data, technical data, which are very important by choosing the suitable inverter for the for the suitable or for the design PV system. And as you see, actually, these two parts here, also either a standalone system or as connected system, we can connect or install these systems either in small projects, small workplaces of handicrafts, or on the training centers, also on the ceilings of university or another buildings, governmental buildings, or other buildings where we can use solar energy and to reduce CO2, of course. No? That is our photovoltaic system at the ceiling of one building of our university in Högsta, and that is the inverter, that is string inverter. As you see here, the capacity of this system is about 30 kilowatt. It will be replaced with more efficiency plant, photovoltaic plant. But it is installed since more, I think, 20 years or more. Yes, the capacity is supplied actually to the basic load of the location here in Högsta. So that is, again, that is the picture for where you see here the inverter. You see in every string there are inverter. There is inverter to invert the energy from direct current to alternating current. Okay, and that is here the some references what I used or take, and that is big solar plants which can be used to supply access to the grid directly. So many thanks for your attention, and if you have a question, you are welcome.
Many thanks, Dr. Salman, for your lecture, and many thanks for organizing this workshop. We all enjoyed the lectures and the diversity of the lectures. If we have any questions, please to Dr. Salman. Else we can conclude by a statement from Professor Salman.
Yeah. yes. Thank you very much again, Dr. Luai. When no scientific question, we can close the workshop. I would like to thank all attendances of this workshop. That was, I think, for us, a very good opportunity to make some lectures or some presentation from site THOVL, OWL, also Universität Ostwestfalen-Lippe, THOL, yes. And I think, I hope that is was interesting. This workshop was interesting for the attendees, and can give a new idea or new impulses in the project. to make the output, the general output of the project more effective and more interesting. Yes, and I would like again to thank you for organizing for cooperation. Nice and effective cooperation by organizing this workshop.
It's a pleasure. It's always a pleasure to work with you, Dr.
Thank you very much again.
Thank you very much. And I think we have another meeting to catch.
Yes, I would like also to thank all presenting or my all the presenter or lecturer of this workshop, my colleagues and the PhD students also. Thank you again.
Thank you very much. Thank you. Cheers.
Thank you.
Bye.
Okay. Thank you. Bye bye. Yeah, we meet us directly in the next workshop.
The next meeting. Yeah.
Thank you again.
Thank you very much.
Thank you.
مع السلامة.
يعطيك العافية دكتور سلمان، يعطيك العافية.
أهلا الله. شكرا.
شكرا لكم ويعطيكم العافية. الحقيقة كان ورشة متميزة، صحيح وقت طويل بس كانت كلها فائدة وقيمة مضافة لكل اللي حضروا ورشة العمل.
شكرا جزيلا.
شكرا جزيلا.
شكرا دكتور، يعطيك العافية.
الله يعافيك. شكرا
جميعا. شكرا للجميع.
شكرا. مع السلامة. هلا دكتور عدنان. هلا.
إن شاء الله بنشوفكم بخير كلكم.
إن شاء الله.